Good morning, everyone. Today's webinar marks a real milestone in several areas. If you've been attending our recent webinars, you've heard me mention new records for registrations. This webinar is no exception in setting a near insurmountable record of 1,019 people registered. Way to go, folks. Thank you very much for your support. Secondly, for the first time, you will hear from a honing expert and a ring expert on cylinder finish and how it relates to the performance of your piston rings in one webinar. Ed Kiebler of Rottler Manufacturing will talk about the honing processes, and Keith Jones of Total Seal Rings will bring in the rings into the equation. But we're not through yet. I'm pleased to let you know about a late addition to this webinar. Lake Speed Jr. will moderate the discussion in an attempt to keep some semblance of control. Not really. His role is to keep the discussion on point and somewhat on time, but don't be surprised when Lake jumps in with some comments of his own. The 2020 webinars are being sponsored by CWT Industries, the Durbon Bearing Company, ERI of Canada, Hastings Manufacturing Company, King Engine Bearings, Mala Aftermarket, Qualcast LLC, and Rottler Manufacturing. These sponsors allow us to present these webinars at no cost to you. The support of these sponsors is greatly appreciated. Please note that you may have to adjust your speaker volume to a higher level during the highlighted sponsor videos. If you still have difficulty hearing the message, I assure you the sound is adequate on the recording. Our first highlighted sponsor today will be Hastings Manufacturing. Here's a part of a video on their Czech Republic piston ring plant in Buzaluk.
The company Buzaluk in Komarov, Czech Republic, ranks among the world leaders in supplying parts for the automotive industry. 420 employees work in the piston rings division. The company has over 80 years of experience in production.
Divize písních kroužků se zabývá výrobou písních kroužků, těsnicích kroužků do spalovacích motorů a hydraulických aplikací a dále výrobou odlitků a obráběných odlitků. Písních a těsnicích kroužků ročně vyrobíme zhruba 25 milionů kusů. Ohledně odlitků a obráběných odlitků tam se blížíme číslu milionů kusů ročně.
The heart of the company is two foundries, where master smelters cast tens of thousands of tons of molten iron every year, with laboratory assistance and its rapid reaction through the pipeline post.
Nyní se nacházíme ve slévárně písní kroužků, která vyrábí tvárnou a šedou litinu. Za mnou vidíte naše středofrekvenční indukční pece. Máme v současnosti v provozu 4 pece, 2 dvoutunové a 2 jednotunové, kde provádíme tavení ze surového železa a plus vratného materiálu.
In the piston rings division, company employees design, develop, and produce both cast iron and steel piston rings, as well as sealing rings in the number of thousands of pieces.
Probíhá tady obrábění do správného tvaru ve volném stavu, který je rozhodující pro to, jak ten kroužek funguje a jaké má vlastně parametry a tím ovlivňuje parametry motoru. Velkou oblastí stále nabývající na významu jsou povrchové úpravy, takže tady se dělají v podstatě od standardního tvrdochromování, které jakoby známe, až přes modifikované verze tohoto tvrdochromování, to znamená chromkeramika, vytvoření kanálků sycených tvrdými částečkami pro zvýšení životnosti pro moderní motory, až po stříkání molybdenem povrchových vrstev, anebo nitridace, u které teďka stojíme. Končí se vývoj a začínají se dodávat do sériové výroby kroužky, které mají nitridaci a povlak PVD, což je fyzikální naprašování tvrdých vrstviček na ten samotný výrobek.
Teď se nacházíme na zkušebně motoru, kde testujeme námi vyvinuté písní kroužky.
To see the full video, go to the website on the screen. You can contact Hastings Manufacturing at 800-776-1088 or at www.hastingspistonrings.com. We thank you for your generous support. Our second and last highlighted sponsor will be Rottler Manufacturing. How appropriate. The Rottler H80 series of CNC automatic honing machines have proven in many PER shops that the machines improve quality of the surface finish of cylinder bores while giving shop owners increased productivity, saving time, and making profits. Did you know that every Rottler H80 series hone comes equipped with crash protection? Although using diamond and CBN stones over traditional abrasives may cost a little more upfront, the cost savings over the life of the diamonds and the CBN stones is substantial. The Rottler H80 series is equipped with crash protection to protect the honing head, stones, and holders. This allows you to maximize the life of your diamonds and CBN stones, creating greater savings in the shop and increasing your bottom line. It also has programmable CNC Plateau finishing process. In today's environment with low tension rings and strict environmental regulations, the ability to create the ideal plateau finish is paramount. The Rottler H80 software is equipped with programmable CNC plateau operation, allowing you to easily hit those required parameters, achieving optimal surface finish. It has automatic stone compensation that makes it easy for operators to maintain size throughout the block. It has a removable coolant tank, which makes cleaning downtime less than competitive machines. And finally, the H80 machines have programmable CNC honing load control. Rottler's H80 series hone allows you to set and maintain a desired honing load in order to achieve the optimum straightness and roundness required with today's low-tension piston rings in different blocks, materials, and cylinder wall thicknesses. Contact Rottler at 800-452-0534 or www.rottlermfg.com for further information, and thank you for your support. Now, as always, just a few housekeeping points before we get started. Mic audio is muted for all the attendees. If you have questions during the program, you need to type them in the control panel at any time. Today, we're going to hold questions until we get to the Q&A time at the end of the presentation. This webinar is being recorded for later access. Everyone registered will automatically receive a link to the recording. The recording should be available no later than Friday morning, October 23rd. The link is also will be posted on our website at www.pera.org, where you can find links to all past recordings on the webinar page. This will now give us 63 recordings through our website. And lastly, GoToWebinar is now offering a certificate of attendance for all of you who watch the webinar live. You'll receive this link to download the certificate with your thank you for attending email. Ed Kiebler has spent 44 years in the engine rebuilding business in various functions, the majority of being in sales and product management. 34 of those years were spent with Rottler and Sonnen. The remaining 10 were spent between Storm Vulcan and Winona. His responsibilities have included product innovation, testing of new products, product procedures, and training, along with the managing of salespeople and customer accounts. Ed says, I have spent 32 of those years traveling the world, calling on customers, learning what they need to help their business in the way of machines and tooling. Who better than Ed to tell us about these challenges and how to overcome them? If you sat in on last month's webinar on piston rings, you quickly learned that Keith Jones lives up to his title as a Director of Technical Sales for Total Seal. He's managed the technical team at Total Seal since 1997 and has been a part of the development of many of Total Seal's products. He's been around racing and race engine building since growing up in the western suburbs of Chicago. He says it's in his DNA. Lake Speed. What can you say? As I said in the introduction, Lake Speed Jr. has stepped in to moderate the webinar to keep us on track and to point. As you can see on the screen, Lake has an extensive background in engines, lubrication, and pretty much all things automotive. In this webinar, Rottler and Total Seal team up to discuss the science behind what makes a great finish. Ed Kiebler from Rottler will explain and demonstrate how proper honing techniques produce the right surface finish for optimal piston ring performance. What is the ideal finish? How can this be obtained? How can it be measured? And what does it all mean? Keith Jones from Total Seal will package it all together from the ring's point of view and discuss the critical relationship between the two for optimal performance. The webinar will be done at location in Charlotte, North Carolina at Robert Yates Racing. Before I turn this over to Ed and Keith, please remember that if you have any questions, you need to type them into the question box, and we'll have Ed and Keith answer them at the end of their presentation. So let's now hear from Ed Kiebler of Rottler Manufacturing and Keith Jones of Total Seal Piston Rings.
Good morning, everybody. Thanks for attending. This is Keith, by the way. I just want to say thanks for doing this. Appreciate you taking the time out of your day. I know you're all busy. You got a million things going on, but appreciate you taking the time to listen to us. Kind of bend your ear and chat it up a little bit about rings and cylinder finishes.
And this is Ed Kiebler from Rottler Manufacturing. I'm excited to be partnered up with the fellows from Total Seal and Keith Jones. I've listened to him speak throughout my career, and I don't know that there's anybody more knowledgeable when it comes to rings than Keith Jones. So I'm excited to be here. Thank you.
All right, well, let's get going.
And I'll just say right back at you, Ed, and we've got Lake there, so got to introduce our good friend and cohort in crime, Mr. Lake Speed.
Thank you, Mr. Jones. I appreciate that. And well, I can't see that everybody can see our webcam, but we're sitting here, Ed and I, in the conference room at Roberts Yates Racing Engines here in Mooresville, North Carolina. And so you can see some of the trophies there in the background. Obviously, Robert was a legend in the industry, yes, wonderful man. My dad got to drive for Robert a little bit during his career, so it's very honored. Thank you to David Lewis and Jimmy and Doug Yates, everybody that allowed us to come in today. So since we can't give you a virtual tour of the shop, we threw some pictures up of some of the items out here in the shop today so everybody can see it. So in fact, yesterday, Ed and I were here working from information that Keith gave us to help the guys here at Yates with the new dart block, yes, they have for the NASCAR spec motor that is a aluminum block, but sleeved, pretty hard sleeve,
yes,
without giving away the whole webinar. So we were working on different abrasives, yep, to try to reach the numbers that Keith had provided for. This is the ring material, this is the fuel application, here's the surface finish numbers we now need to achieve. And we were working with the H85 to achieve that, right?
Correct. Yes.
So I should have thrown some pictures in this morning of the results we had,
yeah,
but we can get there maybe in the question and answer section.
Yep.
So that's the shop, and really what we were just kind of talking about, looking at the profilometer numbers and why the profilometer numbers are important. And I'm going to let Keith really kind of handle more of the first part of this, going through those numbers. It goes back to good guy worked with for years that taught me a lot, Scooter Brothers, and I'm quoting Billy Godbold, quoting Scooter Brothers. You can't change what you can't measure. Billy was always wanting to get new CNC machines to CNC grind cams, and Scooter's like, you got to have an ad coal to be able to measure what you make before you start making things you can't measure. So with that being said, let's get into what is a micron, because when we're talking about measuring with a profilometer, we're looking at measurements that are in the range of a micron. So Keith, why don't you give us a little bit of an idea of what this actually means and how it translates into engines and surface finish?
Well, one of the things that we've run into, over the years and years is just kind of misconceptions about how deep, how rough, how aggressive these scratches are that we're putting into the bore. And very commonly, and these are things that we'll go over, of course, as the program proceeds on, but very commonly it's misconceived that these are very deep, very large cuts. I get so many people, they'll bore a block to within 5/1000ths of size, and then they'll rough hone it to within 2 or 3 thousandths of size, and then they'll come back in and use this next stone to bring it almost to size, and then this stone to get it to size. And then, we put in this multiple step, 3, 4, 5 different processes, not realizing that these are microns. This is micro inches. These are extremely small cuts. We're not talking, thousandths of an inch here, folks. As you look at the illustration there, you can kind of see the differences between, the thousandths of an inch, the diameter of the human hair, and I would just say my eyes are so bad I can't quite read that, down to a tenth, and then down to the micron. And I got to tell you, I can't quite, I got like a quadruple focal on these glasses, and there isn't one spot that's quite right for that. But all the way down to the micron, and how small these cuts really are, how very minute. So if we do too much before what I want to call getting it to size, that step in the process, you can and will wipe out everything that was done before that. You may think that you left this deep cut, this deep valley, all these scratches in there, but they've really been wiped out because we put so many steps into the process. Again, not making that realization of how small these cuts really are. They are, again, measured in micro inches. They are very, very tiny. And it's so important to get these figures right. If you kind of think about, and maybe I'm jumping ahead just a little bit here, oil on the cylinder wall, you know, that oil is the sealing effect, and it's such a critical thing. And it's just, if you think about it like this, if any of those out there have ever painted a car or worked with, you know, paint on steel, you know, that, you know, the preparation of that surface is the key. You'll hear this many times, and no offense to anybody out there that sprays paint. You know, everybody you talk to that paints cars like, shooting paint's easy. It's the prep work, it's the body work, it's the hundreds of hours put into that prep prior to squirting the paint on there. You know, if we don't get the surface right, it's wavy, it's wrinkly, it's lumpy. You know, if we don't get the finish right underneath it, you know, you see the scratches through the paint, or just the opposite, which kind of applies to us. If we don't get the right scratches, guess what? The paint falls off. It doesn't have anything to grab a hold of and cling to. So getting, you know, these scratches to be the right size is such a critical thing.
Yeah, well said, Keith. I mean, as a former paint and body guy, as a kid growing up in NASCAR, with a dad having the race team, that's the only thing they would let me do is work on cars, you know, doing paint and body work. I did a lot of paint and body work, and buddy, yeah, I'm with you. Amen what you said, because it is all about the prep work, getting that surface finish right. And you know, I guess the one takeaway from this screen is we want to make sure everybody pays attention to is that 1/10 of a thousandth is 100 microns. So if we don't remember anything else from this one slide, as we move forward, remember 100 microns is a 1/10 of a thousandth. That's the key thing as we move forward, because like you said, Keith, you're dealing with things that are on this micron scale. So you can see these scratches, and a profilometer is a fantastic tool to measure that, because those scratches and the surface texture is too small to see with a naked eye. Yeah, you can see some variations, and you can see the angles and that, but to really characterize that surface, you have to have the profilometer. And so at this point, back to, we were just saying, the 1/10 of a thousandth is equal to 100 microns. Keith, tell them what we're looking at here.
Well, what we're looking at here is the screenshot of the Mitutoyo SJ201, and what we're looking at basically there is the surface finish. If you can connect this particular piece of equipment to a computer, you can download their software. It's all free, and you can actually save this data, print this data, expand this data, blow it up. You can add a ton of different parameters, but very simply speaking, what you're seeing is a relatively nicely plateaued surface across the top. You're not seeing a lot of upward projecting profile there. And at the same time, we're seeing a lot of downward projected profile, all the deep scratches going down, or the deep lines going down on that screen, indicating good valley depth, good oil retention, the ability to trap oil, the two different areas in the surface, the area that the ring's going to see and the area that the oil is going to see. And such an absolutely important, you know, we'll say monumentally important part of getting in maintaining good ring seal. As Lake was saying, just because we see the scratches don't mean the scratches are right. There was an email that we were kind of involved with, started the day before yesterday. You know, Lake was on it, Ed was on it, I was on it with a gentleman talking about a boosted small block Chevy, and you know, digging down through there, he started off with some pretty generic information, and come to find out it is a dart block. It's 35 pounds of boost. It's on alcohol. And then we come to find out how much time is actually on this engine. And since he could still see some crosshatch in the bore, he thought it was okay just to run a dingle ball hone through it and throw it back together. And though it is working now, it's not working the way it was. And it all comes back to that. So just because you can see the scratches doesn't mean those scratches are right.
Yeah, like I said, back to the Scooter's quote, you can't change what you can't measure, and the profilometer gives you that tool to be able to measure exactly what that surface finish is. And one thing we were talking about the other day, when you look at that screenshot of the profilometer results, that scale is plus or minus 200 micron. So if you imagine each of those little blocks on the screen is 100 microns. Back to a tenth of a thousandth is 100 micron. So if you take out 5/10 or 3/10 finishing or plateauing, those valleys are gone.
Yep, absolutely.
Yeah, why don't you talk about it, Ed, a little bit about what you've seen, experience, and what you recommend based on that?
Yeah, no, it's absolutely correct. Like one of the things that I always say about the surface analyzer is when we're trying to obtain plateau finishes, you know, this isn't a process to where I throw a rough stone at it and then I throw a finished stone at it and then I do a trace. This is a science. And so as we're trying to acquire the proper finish, we're testing or we're measuring our surface finish at every step. So we throw a base grit diamond in there, say it's a 180 grit or a 270 grit or whatever it may be. And then the first thing we're going to do is just hone thousandths or 2,000ths out of that cylinder and take a trace. And I want to see where our RVK number is at, because as Keith alluded to a little earlier, you know, about the paint analogy and all, we need something that oil can grip to, and that's the valleys or the RVK number. And so it's really important to have enough RVK initially to be able to plateau those peaks or the top surface off to allow for the rings to see a nice plateau.
Yeah, your 1200 grit diamond isn't going to add any more valley
No,
to it.
no, absolutely not.
You can take the peaks down a little bit, but it's not going to add any valley.
Right.
Okay, so Keith alluded to it earlier that, and you just mentioned it too, Ed, that the oil is the gasket that seals between the ring and the ring land and the cylinder wall. So if there's no retention of oil on the cylinder wall, then essentially there's no gasket to seal the ring to the cylinder wall.
Right, that's absolutely correct. Yes.
So the goal of the whole honing process isn't just getting the cylinder straight and round.
No,
Which is
that's important. It's very important. But cylinder wall finish has become much more important. And Keith, you can probably allude to that. You know, you talked. We were having a conversation the other day, and one of the things that you brought up was the old Moly rings versus the new style rings and the ability to hold oil and all. And people say, well, why have these cylinder finishes changed over the years?
Well, and that's a great point. And this is one of the things I'll throw out there. So for all of you that are listening right now, and you can throw your hands up in the air, how many of you have used a chrome Moly ring in the past? I see a lot of hands that went up. And to answer that would be, there is no such thing. When we're referring to the chrome Moly ring, you're referring to the coating that's on the ring. Chrome Moly is tubing. It's what we make race car chassis out of. That is referencing the coating. That's the face coating of the ring either is chrome or it's Moly. It can't be both. Now there is a time years ago when you could get a set that had a chromed top ring and a Moly coated second ring, and then that kind of evolved into the double Moly, and I'm air quoting by the way, Moly top ring, Moly second ring, but that stuff is really pretty much all gone down the wayside. So with that said, molybdenum or Moly style coatings are very, very porous. You can see up to 40% porosity in the face of that ring, meaning it's very oleophilic. It wants to suck oil up like you can't believe. It's holding oil like a sponge. So it really lets you get away with different surface finishes. You might get it a little too rough. Hey, it's going to get away with it. It might be a little too smooth. You're going to get away with it because the molybdenum is holding enough oil to counterbalance the deficiency in the cylinder wall finish. As we've moved into modern style coatings, where we're getting into hard coatings, PVD applied, chrome nitrides, gas nitride rings that really don't have any coating at all, titanium nitrides, we're getting into these much harder, more exotic thin film coatings. These don't have the oil trapping or the oil ability to absorb oil as a molybdenum-filled ring. And this is, again, part of why engines go 250,000 miles. I mean, there's many, many reasons between material technologies, coating technologies, oil technologies. But, we all remember the old days when, 70, 80,000 miles on your small block Chevy, you're saving your money because, man, if this dude makes 100,000, I'll be surprised. And that's part of it is the material technologies, the block, the rings, the oils is all changed. So we have to look at changing bore finishes to get that oil trapping. If the coating on the ring's not going to do it, I have to make the cylinder wall do it. Something has to hold the oil. Rings ride, as illustrated here, the ring rides on a film of oil. It also encapsulates inside the ring groove. It lubricates. It helps to move heat out of all the parts, get the heat out of the piston into the cylinder wall to the water. The heat has to go somewhere. One of the things to also remember is the piston is constantly accelerating and decelerating. One of the things that we look at is and Lake can really expand on this, is the boundary layer, how the ring rides on the oil film and how that changes throughout the stroke of the engine. And I'll let Lake kind of grab onto that one.
Well, yeah, obviously they call it the Strybeck curve, which is defines oil film. Everyone can think about oil film, and the best analogy is water skiing, in my opinion. When the boat's not moving, the skier's in the water. Absolutely, he's wet. Then as the boat begins to move, the skier begins to come up out of the water, but there's a moment in time when you're not fully out of the water yet. The boat's not on plane, the skier's not fully up. But then as the boat reaches speed, then the skier is up on plane. So those three scenarios, in the water, halfway up, and then fully up, in lubrication terms, we call that boundary condition. That's metal on metal. That's the skier in the water. There's no motion, and it's metal on metal. That's your flat tappet cam against the cam lobe and push rod. That's those high load, low speed areas. That mixed film, that transition, is just what we call it, mixed film. So there's some metal on metal contact, but there's mostly an oil film. So you have maybe those peaks just touching each other. But then when you get into full film, that's the boat moving fast. Well, you think about a piston, as Keith was saying, it's always changing direction, changing speed. At mid-stroke, the piston is moving as fast as it's going to move. It's in that full film station there. But as the piston is nearing top dead center, especially on a compression stroke, now you have increasing cylinder pressure driving the ring out against the cylinder wall while you have decreasing speed. So the piston is basically, actually the piston ring is what's going from full film lubrication through the no wake zone to fully stopped. And at that point, to protect the ring, because it's a lubricated component, not just a sealing device, but also a lubricated wear component in the engine, now you need to have that additive film to protect the ring near ring reversal. So mid-stroke, that's all about the oil doing the hydrodynamic wedge. But as you get into those higher pressure situations, we're back to boosted applications, when you're running E85, all that stuff that can wash the lubricating oil away from the cylinder wall, that's where it becomes really key to have enough oil, because proper lubrication can be defined as having the right oil, which is the right additives and the right viscosity for the application. So the right oil, right place, right time, right amount. Not enough valley, not enough retention at the top of the bore, there's not going to be enough oil there to lubricate the ring, especially in a high fuel dilution environment where you can get into problems. As Keith, you mentioned earlier, the molybdenum coating in its porosity is forgiving because it can hold that oil, but it does have a downside. What was the Brunel hardness or the Rockwell hardness of those old Molly rings?
Oh, she's pretty. Molybdenum itself is a fairly hard part. So numbers-wise, it's typically about in the Vickers world, typically about 850 Vickers, 900 Vickers. Where you start moving into the modern coatings, chrome nitrides are generally 1700, titanium's 2300. So it's hard, but it's not hard. Chrome, like hard chrome's about 1000. So it's definitely on the softer end of the scale. But one of the real issues with that type of coating, and especially in today's world, is one of the things Lake had mentioned earlier about working on low-speed pre-ignitions, LSPI. And, you know, the engines that we deal with today almost always run at some point in time in some kind of a knock condition. And molybdenum is a forgiving, lubricating style coating. It likes to hold oil. It really doesn't like piston rings very well. It doesn't like things that modulate and vibrate and do a lot of shimmy shake while they're running, and the coating flakes off. It doesn't stick very well to the ring. Molybdenum has always had, on its best day, we'll say a love-hate relationship with the ring as far as from an adhesion point of view. Any of us that have dealt with engines, you know, supercharged, turbocharged nitrous and stuck a moly-filled ring into it, it doesn't take much of a rattle to knock that coating out of the ring. And when that coating comes out, it can do a lot of damage, a lot of devastation. And that's a big part of why over time, as rings have gotten thinner, cylinder pressures have gone up, horsepower numbers have gone up. We've really kind of steered away from that coating because it has some great attributes, no doubt, but the negatives in today's world far outweigh that, and we run into some serious, you know, very serious issues.
It's that Goldilocks and the Three Bears. I see it all the time. Not too hot, not too cold, just right. It's you don't want too much oil up there because that can lead to detonation, as you said, Keith. Don't want too little oil because then it's lack of lubrication. And so, yeah, the moly's got some advantages, but it also has those drawbacks of not really wanting to stay on the ring because it's a different material and can flake off, and then excess oil retention can be a problem too. So that's the reason for moving to the newer coatings. And when we go to those newer coatings, because it doesn't retain the oil, now we have to basically build that into cylinder finish.
Cylinder finish, yep.
All right. Oh, look, it's like we written a slide for that or something. So we basically what you're just saying, right? We just need the cylinder wall to retain that oil so it can provide that seal. And so, Keith, why don't you give a little bit of the 101 on the different values? So RA, RPK, RVK. It sounds like alphabet soup to a lot of people, but these are the critical values we need to address.
Well, absolutely. You know, if you think about it, not that long ago, we really didn't measure anything. You know, we just kind of did this very blindly and based on the information that was passed down, you know, from, you know, grandfather to father, father to son, you know, friend to a friend, however that information was passed down. And, you know, the things that have really changed is, you know, again, we just talked about coatings on the rings, ring materials themselves, but the blocks, you know, I've been doing this a long time. Most of the people out there have been doing this for quite some time. And we all know how much harder these cylinders are today. You know, Lake and Ed had mentioned earlier about working at, you know, at RYR and working with the new block and how much harder the sleeves are. And that's really the thing that is, you know, the whole point of this discussion. If we go back into the 70s and even into the early 80s, you took a look at, you know, a small block Chevy, you know, Buicks, Olds, Pontiacs, all the different blocks that were out there, were all relatively about the same hardness. And then every once in a while you get a guy that, you know, man, I got that high nickel block, or I've got that seasoned block, and, you know, man, is that thing hard. Wow, you should hear that thing squealing when I hone it. And, you know, the production block might have been 150, 160 Burnell. That hard high nickel block on a good day might have been 180. So in the big picture of things, not that much harder, but, you know, the perception of that block's hardness was so much greater. Today, you know, we're dealing with block and cylinder, I should say, hardnesses that range from that 150, 60 range in excess of 500. I've had cylinders come in here that were 550. The whole point is that at the end of the day, the ring, there's certain measurements that we're going to talk about right now that the rings want to see. These are the numbers that the rings need to see to find that happy place, that right amount of oil retention, that right amount of plateau, so they can create that good sealing surface, that, you know, that oil retention surface to get that, to not have blow by, keep it properly lubricated. The thing that is so dramatically different is, how do I achieve those numbers on an 010 Chevy block that is 160 Burnell hardness versus an older darter bow tie block that was 220 versus a newer bow tie block or newer dart block that's closer to 300, or a newer sleeve that's over 300, or I've had some cylinders come out of some European stuff that were over 500. These are all very, very different honing processes. Yet at the end of the day, I'm still trying to achieve the same basic numbers. That's the reason we have to be able to measure cylinder finish. And in the very early days of this, the availability of equipment that would measure the kind of numbers that we really need to look at was very, very limited. So again, 80s, 90s, we were pretty much looking at RA, arithmetic average of roughness. So we're looking at numbers here that are taking and averaging, what are called the peak heights, the peak to peak distances, peak to valley height numbers, and kind of blending all these numbers. They're giving us a roughness number, but they're really not talking about the ability of that surface to bear a load. And that's what all this is about. Everything here is about bearing a load. As Blake had mentioned, the rings coming up on speed, that oil retention, all of that is about how it bears the load. As the cylinder pressure is trying to push the ring out onto the bore, as we're approaching, top dead center on the compression stroke, we're coming out of the power, into the power stroke or ignition, sitting at TDC with a very, very limited low speed movement of the piston. It's really not doing much. We're putting all that cylinder pressure, trying to push that ring out and literally punch it through the oil film and go metal to metal. That's why having that surface that will bear that load and keep that lubrication there is so critical. And what we found out over time is simply using RA numbers were very deceptive. As you can see in the illustration, both of those illustrations. If you look at the top illustration, we've got a very nice flat top, a good plateau with nice deep cuts, good valleys. But if we simply flip that illustration over to where we've got nothing but peaks, no valley, no oil retention, and we're simply using RA numbers, because we're averaging, it's the same surface finish. So we could have a great RA number. If somebody told you, hey, you need to hone that to an RA of an 18 or an RA of a 20, well, you can have an RA of a 20 and absolutely have a completely different functionality to that cylinder finish. And that's why we've not used RA in quite some time. Once we were able to get into equipment that has the ability to measure the true numbers we need to look at, we've gotten away from RA.
So here they are. So give them a little bit of background. So obviously, there's a bunch on here, and we won't go through all of them, but there's two on here that we really need to focus on. Which two are those?
Well, there's actually, I'll kind of expand on a few of these. There's a few numbers here. Once we start getting away from from RA, we need to look at the numbers that we'll talk about peak heights, valley depths, and that core area, which is really the bearing area here. And if you look at the illustration, you'll see the area illustrated as RPK. That's your peak roughness. That's the roughness area that the ring itself is actually going to come into contact on a cold or a dry start. That's the area of the roughness that the ring is going to see in that ring reversal period of time where motion has stopped. We're changing directions. We've lost that wedge of oil. That's the surface roughness area that the ring is actually going to see. So if we get that RPK number, that peak roughness number too high, it's going to be very aggressive on the ring. It's going to want to scratch it, tear it up. It's going to do damage to the ring. And then, of course, the ring is going to repay that kindness by taking that damaged face of the ring and in turn scuffing up the cylinder itself. So we can't let that value get too high because it's very aggressive on the ring. The next value below that, and hey, look at that technology. Look, Mr. Speed, look at that. we're coming into the RVK, and that's our valley depth. That is the critical area. That is the oil retention, and that is RVK on that screen. Yes, it is. I had to get real close to see that, by the way. So that ability to hold and bear that oil. Just about talking about the paint earlier, we have to give it, think of it like as like a tooth. Just because we're throwing oil up into the bore, we've got oil sprayers, we've got all this happening in there. If the rings are doing their job, which is to wipe and return that oil back to the sump, back into the pan, they will do that. They will do it well. And if we add things like vacuum pumps and dry sump systems that are all inducing a vacuum into the bottom end or introducing a vacuum into the bottom end, trying to pull that oil back down away, if I don't give that oil something to grab onto, something to cling to, think of it as like a rung on a ladder. If you don't have something to grab onto and hold onto, you're going to go boom. You're going all the way back down. The rings are trying to wipe any excess oil amount off that bore and return it to the sump. The critical valley number is all about trapping that oil, finding the right amount of that valley number, depending on the application, is critical. We get into engines that are turbocharged, alcohol, methanol, E85, where we're putting copious amounts of fuel through the engine. Well, we have to compensate for that with the RVK. We have to increase that number to get more oil trapping, try to stop that oil dilution, stop that from breaking that oil film down on that bore. Other direction, if we're into very thin, very light, low tension ring packages, gasoline, we might be able to reduce that volume number. So that RVK becomes a very, very critical number based on the application, because we have to have that depth. We have to have that oil retention, that oil trapping. It's such a critical number. If you can back up to the last screen, if you don't mind, I want to touch on something else.
Sure.
One more, please, if you don't mind.
There it is.
Okay, on there there's also a couple of values on there. Just below the RVK value, there's the MR1 and the MR2, and I just want to touch on that just a little bit. Those are numbers, if you have an older profilometer that doesn't have the ability, and like everything, technology's changed, and the access or ability to buy these machines, prices have come down significantly. We have access to equipment that we didn't have access to, 10 years ago, 15 years ago, 20 years ago, that give us more and more data, more and more knowledge. The MR1 and the MR2 are part of what is referred to as the Abbott-Firestone curve. And these parameters talk about what is referred to as, we've said all along, the bearing area, the ability to bear a load. If you have an older profilometer that doesn't have the ability to measure RPK, RK, RVK, we can still work with that machine. And you can reach out to us after this when we get into talking about percentages of MR1, MR2. Those numbers speak to how much material area there is above the mean center line versus below the mean center line. So we can look at that RA number. Remember, we talked before about not being able to describe that. We can't define it because we don't know, is the peak going up? Is the peak going down? But working that number with the MR1 and the MR2, we can kind of make that decision. If we've got 7-8% in the MR1, we've got 78% into the MR2. We know what percentage of material has been removed, how much has been removed up here, how much has been removed below. And we can kind of work with those numbers if you have an older machine. So we can talk those numbers as well and talk about that bearing area curve. So just wanted to just touch on that for a second. Thanks, guys, for backing that up.
That's a great point, because you're right. Some of the older machines do have that, and it doesn't really matter which method you're reporting it is, because as long as you get the same concept of, hey, we've got to have less RPK, we need to have more RVK to hold it. So Ed, why don't you give them a little bit of, okay, those are the numbers, but as we kind of work toward the end, what are the grits? How do we go about achieving those numbers from a abrasive selection?
Sure. So again, I alluded earlier in the conversation about the first thing that we have to look at is what RVK number we want. That's the critical area. That's the first thing we want to look at. And depending on, as Keith was saying, naturally aspirated versus turbocharged or blown or what have you, you want deeper valleys in the higher combustion pressure engines than you would in a naturally aspirated engine. And so you have to start with a rough enough finish in order to leave those valleys once we have plateaued over the top to give the rings the proper finish to do their job. And so typically we're going to start anywhere from an 80 grit to a 325 grit base finish diamond, or a diamond to put our base finish in, and then we're going to plateau over the top of that. Now that seems like a pretty wide range, and the only reason that you would really use the 80 grit in any applications that I know of is, as Keith refers to them lovingly, is the crazy diesel guys. You know, the guys that are just putting unimaginable amounts of pressure, fuel, and boost into their engines. So again, we have to have that RVK number to begin with.
And what, like the diesel blocks, like if you're doing a Cummins block, how hard is that Cummins block relative to, say, a small block Chevy, or just traditional small block Chevy?
Yeah, it's as a rule, it's going to be 100 points on the Burnell scale, higher than at least than a small block Chevy.
Okay.
And that kind of brings us to another thing is, you know, with all these different needs of the rings for RVK and RPK, it can get very expensive to have to purchase different grit sizes to accomplish all of, you know, most engine builders, they're not focused on one particular application. They may do anything that walks in the door. And then you're also dealing with the different Burnell hardnesses in the blocks, you know, anywhere from a small block Chevy to the Dart blocks, the cast iron blocks, or the Darton liners, or what have you. And so what we have found over the last few years is we recommend 180 grit diamond to put your base finish in. Now, in maybe 60% of those blocks, our RVK is going to be too high to start with. But that's kind of the neat thing about this plateauing process. Now I can take a 600 grit CBN abrasive and go over the top of that rough finish, and depending on how many strokes that I use and how much pressure I use, I can vary that finish dramatically. I can have as much as a 60 RVK, and by applying a few extra strokes or a little bit of extra pressure, I can get that RVK down to below 20. So it really works well in a multiple application scenario, to where we go in with a base finish of say a 180 grit. Now, if you get into the really hard blocks and the really high boost stuff, you'll probably have to drop down to a 140 grit, or maybe even an 80 grit. But as a general rule, that 180 grit really works well for most applications, because we can vary how long we stay in the cylinder with the 600 grit CBN, so to speak, and get the proper RPK finish then.
Got it. Okay. So to kind of tie all that together, back to what Keith was talking about, your bearing area curve is what we're looking for. That if you have too many peaks, then you don't have much load carrying capacity. When you go down to the very bottom one, that's what we're looking for, is that plateau with those valleys to hold the oil that can bear the load. And as you were just talking about, if you start with a fairly rougher abrasive to begin with, it allows you to establish those valleys. Then you can control how much of that valley you leave with the finishing, your plateauing process.
Yes, sir.
Okay. So here's some of the numbers that.
Well, hey, Lake, if you don't mind, if you could can you back up just one slide? I don't mean to interrupt you, brother. Just wanted to touch on that, and that's something, you know, the bearing area curve picture. If everybody kind of pictures it like this, think about, you know, look at the graph that you see on the left, and then look at the percentages you see on the right. So think about it like this: when you've got that ring in that cylinder, and we actually have a slide that we've done that actually shows the pounds per square inch. Think about this as pressure. That ring's pushing down, and we're concentrating all that pressure on that real sharp little peak, that sharp little tip. So my pounds per square inch on that little tip, or on that peak, can be in the tens of thousands of PSI. That's trying to, again, push its way through the oil film, contact the ring, scuff it, scrub it, and create all kinds of wear problems. As you notice, as each one of these start to plateau down more, all the way to the bottom where we've got a beautiful plateau, look at how wide and flat that contact area becomes, and then drops quickly into the valley for oil retention. So as we begin to flatten that profile out, or put more plateau into the cylinder, we are reducing the pounds per square inch of the ring, you know, the unit loading across the face of the ring onto the cylinder wall. So we're effectively reducing drag, we're reducing wear. We're also affecting the things the ring does naturally. So rings naturally plateau bores. If we all think about, again, back to the old days where we went in there with a 220 grit stone, called it good. That was it. Plateau, what's a plateau? And that's something out west, they sit on top of the mountains or between the peaks of the mountain. What is a plateau? We would come in, single stage hone it, ship it. And we always had the days back then where, it's going to take 1,000 miles to seat the rings up, or 2,000 miles, 5,000 miles. I remember reading a GM technical bulletin in the early days of the LS when they really had some massive oil control issues, and that bulletin read 7,000 miles. They wouldn't do an oil consumption analysis until it had 7,000 miles on it, because they considered that the period of time it took to seat the rings up. And that seating is really cylinder wear. That is what we're truly seating. That's the area that we're doing the metal working on. The break-in process is that last metal working function of mating those parts up, just like flat tappet lifters to camshafts and brake pads to rotors. We've got to let those surfaces wear in. And my point is, back in those days, we accepted that it took that long. Well, today, we want it now. We want that engine to go on the dyno, 3 hits, it's good as it's ever going to be. We want it to start up and immediately no smoke, no oil consumption. And that is all a function of getting that plateau, getting those surfaces to come together quickly. If you miss the cylinder finish and it's this nasty, aggressive thing, over a period of time, the rings are going to correct that finish. I promise you. Take that engine, run it 1,000 miles, pull it apart, check the bore finish in the bottom where it's never run, check the cylinder finish where it has run, and you're going to see that plateauing effect. Rings will do that on their own. But how many of us want to wait for that anymore? We're not willing to wait that period of time. Over the years, I've had people call me and, hey, we're on the dyno. She's 12 hits in, 15 hits in. She's getting better. She's getting better. And that right there, that tells me right out. 99% of the time, we've got a cylinder finish problem. They've put way too aggressive a bore finish in it. They didn't get a good plateau. And this is the period of time that it's taking for the rings to wear that plateau in. Again, folks, if you've got the finishes right, it's practically instant gratification. You're in, couple hits, done, good as it's going to get.
Yeah, like you said, it's the ring is going to that last area. I just drew the red around that area. Over time, the ring will plateau it. So yeah, you may not be, as you said, plateau honing in the hone tank, but you're still plateau honing. You're just using the ring and the motor oil as the honing oil. That's the thing. As opposed to using honing oil in a stone, you're using ring and motor oil. Yeah. That's still going to do the same thing.
Absolutely.
And the problem is all of these parts are now moving through your engine.
That's right.
That's the downside.
I was just going to comment. All of you that have had that, that gray, fine, graphite-y looking thing down in the bottom of the pan when you pulled it apart, that's your cylinder finish.
Yep.
All right. So here are the numbers. So Keith, why don't you walk through these a little bit? I think we can. This is going to be recorded, so we're getting near the end. This is something people can go screen capture, look back. But if you want to kind of quickly walk through what these numbers kind of mean.
Yeah, so what we're looking at here is, again, we're talking micro inches, microns. So we're looking at, RPK 10 to 15. We're looking at micro inches here. That's the window of peak roughness on the ring. And the interesting thing is that number really doesn't change that much. If we get that number too low, and especially if we introduce a fairly slippery lubricant, again, that, they can expand on, the braking characteristics of oil and how that is really the last machining oil that's in the engine and how important that is. But that number, if we get that number too low, the ring's not going to want to come in very quickly. If we get that number too high, it can be aggressive on the face of that ring on the initial fire up, and in turn, again, return that favor and tear the bores up. So we've got to watch the peak roughness. All the numbers are important. The next one, of course, is the RK. That's your bearing area. That is if you go back to that BAC picture, as you see that flattening just before it drops into the valley, when you start using a profilometer and looking at these numbers, they're not just straight up and down. You're going to go up. You're going to have your peak roughness. You're going to see some real fine lines on the top. Then it's going to kind of drop back down a little bit. You're going to see a little bit rougher lines, and then it's going to drop back down even more into larger lines, and that's your valley. The bearing area, again, is your supporting area. That's the area that's holding the load. Think of that as like the floor of the ocean. That's what the water's sitting on. You know, the Mariana Trench over here, that's miles deep. That's what gives that water something to grab on. But that's the floor that is supporting that oil, keeping the ring from pushing its way through that film. The valley number, the 50 to 55, that's a good typical number for about 90% of the applications that are out there. Your, weekend warrior racers, bracket cars, sprint cars, daily drivers, mild boost, mild nitrous, those kinds of applications. Those numbers are going to get you there for, probably better than 90% of the engines out there. You're going to have a cylinder that's going to seat up well, have good oil retention, good wear life, good ring life. As we move down, as the boost pressures start to go up, as the cylinder pressures start to go up, again, we're looking at that ring trying to push its way through that oil film. So we've got to start to raise those numbers. We've got to introduce a little more valley, a little more bearing area, a little more support for that ring, a little more area to keep that ring, to try to prevent that ring from pushing its way through that oil film, especially during those low-speed operations. We go back to looking at the block. When you pull it apart, you look at typical bore wear. Where do you see the wear? Almost always within that top half inch or inch. Middle of the bore, we rarely see anything. Bottom of the bore, you might see a little bit more, but nothing like you see at the top. There's no, not as much pressure. Obviously, we're not dealing with as much cylinder pressure at the bottom of the bore. So we're going to see that wear in that top part, and that's speaking to that ring is coming through that film of oil. It's working its way through that film of oil. And that can be from an inadequate cylinder finish to begin with, and or fuel dilution. There can be mechanical issues, rings butted in the, butting in the bore, bottomed out in the groove. There's a lot of reasons, but the two that I run into the most are just inadequate RVK to begin with, and or a fuel dilution problem. Now, as Ed mentioned, the crazy diesel guys. Blake's worked with me as a couple of other guys have. I've got a very good customer in Wisconsin, build, as I like to refer to as crazy diesels. These are well over 4,000 horsepower, running on a fuel they call diesel, but I don't think it's the stuff that you go down and buy the number 2 at the station. I'm thinking, toluene, propylene, alcohol, and just about anything else you can imagine mixing into it. So it may bowl black coming out of the pipe, and I'm not sure how much diesel is actually in there. But my point is, I've spent quite a bit of time working with this gentleman on different ring materials, different ring coatings, and Lake spent a lot of time working with him on oils. And no matter what we did, he's tearing parts up. We helped him a lot. We got it a lot better than it was, but really not happy, not good. So then we really started working on bore finishes. And, we'll say, contrary to my thoughts at the time, I'm thinking RVK number of 100. Man, we got to have it knocked at 100. That's got to do it. Well, we get it up to about 100, and it's better. It's a lot better. It's not perfect, but it's a lot better. So now we're on that valley depth. Now we're working that number. And as Ed said earlier, you have to keep going to that more and more aggressive stone, and then checking that finish right at that point in time before you start plateauing. Well, very long story with all this said, each time we got that valley number bigger, it got better. He's dropping crankcase pressures from 10, 15 PSI in the crankcase. At the end of the day, we finally got the valley numbers up to 150, and he's at 0.68 pounds of crankcase pressure, so he's under a pound of pressure, almost ability to pull a vacuum in this thing, and bore wear problems are gone, ring wear problems are gone. So it was simply the amount of fuel that they put through this engine is killing the oil film that badly on the cylinder wall. We've had to raise the RVK value that high. The point with RVK, if you can keep raising that number and not seeing oil control problems, not seeing losses of power, clean, dry combustion chambers, there's really no negative to having that number a little higher than a little lower. As long as we can control that oil and keep that combustion chamber clean and dry and lubricate the parts.
Well said. That's great information right there. So here's a couple more.
I was going to say, and I said, if Ed wants to dive in there a little bit on how to get those finishes, I will say I'm tipping it over to you guys.
All right, I think that's the next section actually. If you don't have any more comments on these numbers, then that is the next section. Is going to talk about that.
Well, yeah, certainly. I just saw that slide flip. Yeah, and same thing here. As we're getting into, smaller rings, lighter rings, thinner ring applications, dry sump engines, engine where we're trying to pull vacuum, we can actually start reducing those numbers. We know we're getting into engines now that are purpose-built. They've got a specific lifespan for them. We know it's got to go out and run, 50 hits in the drag car. It's got to go out and run, 500 laps on the racetrack. And we're typically dealing with much harder blocks. As that hardness number goes up on the block, obviously the wear characteristic improves. We're not dealing with 150 Vernell, gray iron small block Chevy block. We're dealing with, 200, 250, 300, and moving into, Martin Sedek style ductile irons that a couple things. One, they wear much better, but they also don't want to hold oil as well. So we have to get that finished. We have to make it hold that oil. We have to tell it, hey, I'm the boss here, not you, and make it hold that oil. So as we get into the harder blocks and more specific controlled environments that we know it's only got to go this long, we can kind of optimize that bore finish, and we can start dropping those numbers because we know it's only got to last this long. We know the window that engine's got to operate in versus, say, the bracket car, sprint car, weekend warrior, that engine may go out and run 1,000 passes on it. It may have to go 100,000 miles. When we know exactly what that environment is, we can start bringing these numbers down, which again helps to reduce friction, lowers overall drag in the engine.
Perfect. All right. So, Ed, tell us how we go about achieving these wonderful plateau finishes for these different applications.
Sure.
Could we just basically talk through all these things?
Yeah, we've talked about
why did we do all this? Is for those very reasons. So this is what most people are used to using.
Yes, most people are used to using vitrified abrasives, and the vitrified abrasives have worked well over the years. There's absolutely nothing wrong with them. What we have found is with the diamond abrasives, number one, it's much more economical to use diamond abrasives. In a typical vitrified abrasive toning 3/1000ths out of a block, you're going to spend anywhere from about $1.80 to $2.20 per block in abrasive costs. With the diamond abrasive, you're going to spend about $0.05 a block. So it's dramatically different. So that's one of the reasons that we've gone to diamonds. But the other big reason is we're back to that same thing is we see these new plateau finishes as needing a two-step process. So many people using vitrified, as I think it was either Lake or Keith alluded to earlier, is we're gonna rough it to within 3/1000ths, and then we're gonna hone 2/1000ths out with this grit, or 1/1000ths out with this grit, and we're gonna hone another 1/1000ths out with that grit, and another 0.5/1000ths out with this grit. Well, what you've done is you've effectively just gone to a base finish. If you're taking a 1/2 to 1/1000ths out of a cylinder with a different grit abrasive, you are actually putting that finish that particular abrasive will give you as a base finish. There really is no plateau involved. So somebody will ask, well, okay, why wouldn't you use diamond for the entire operation? And diamond is a very hard particle. It lasts very long, but it's a dull particle. It doesn't cut well. It's not a sharp particle. So we tend to, I want to say, plow and kind of smear with diamond abrasives. And the best analogy that I give my customers is if any of you are gardeners or farmers, or you have a garden and you till that ground up really well, and if you were to pull a dull stick through it, you know what happens. You end up with a mound of dirt on either side of that trough along with a pile at the end. If you use a very sharp stick and you pull it through that dirt, you don't get that mounding on either side or that big lump of dirt at the end of the trough or valley. And so we have to do something to get rid of all of that. And we have, and when you use diamond abrasives, a lot of time there's a lot of heat involved and all, because it takes much more pressure to cut. So we've gone to a water-based coolant. Now I know Keith prefers the mineral-based coolant, and we don't. It doesn't matter to us. You can use diamond abrasive. That's another misconception. You can use diamond abrasive with a mineral-based coolant or a water-based coolant. The water-based coolant gives you better heat dissipation than the mineral-based does, but you get some other things that cause problems with gauge sticking and things like that. So So we put a base finish in with a diamond, and then what we do is with Keith's help and Total Seal's help, you know, a few years back, we came up with this CBN abrasive, and the CBN abrasive is really considered a super abrasive, a lot like a diamond, but it's a much sharper particle. Will last not quite as long as a diamond, but many, many, many more times than a standard vitrified abrasive. And so by using the CBN on top, we get rid of all that torn and fragmented metal and all of that, as Keith was saying, all that what you think is graphite laying in the bottom of the pan. The CBN abrasive will really clean that up. So now we're going to get back and what's the next slide? Let's go to the next one, I think. Oh, that's just a picture of the hone out there at Total Seal.
We're doing that was talking about using the water-based.
The water-based, yeah.
As a part of that.
Yeah.
Plateau. That's where we were going with that.
And just to interrupt real quick, hey, I'm down with whatever works for you. And, you know, whether it's a water base or a mineral base, right. It's the product that works best for you in your environment. You know, here we've used both depending on what the machines are, and our machine right now is running a water base.
Yeah, and you're absolutely right there, Keith. You know, if you have a business and maybe you're only honing 1 or 2 blocks a week, quite honestly, the mineral-based coolant is probably a better alternative for you, because water-based coolant, the water evaporates out of the coolant, and so you know it's a process where really once a week you should be doing a refractometer reading of that coolant to make sure that you're maintaining the proper concentration level. The other thing that water-based coolants don't like is inactivity. So if they just sit in there, you know, you'll end up with an algae bloom or something like that. So if you're not using the machine on a daily basis, then oftentimes you might be better off with a mineral-based coolant.
100% true. Yeah, that is the downside to water-based coolants, is you must maintain them. Somebody gave me the analogy the other day. It's like having a hot tub or a swimming pool. You got to maintain the pH. So that's all about maintaining. Again, oil guy, certified lubrication specialist. The water-based coolants do have a lot of advantages, especially the full synthetics, in terms of the cooling ability, but you got to be committed to maintaining them. And then the nice part is, like you said, if you're not running the machine a lot and it's going to sit idle for a longer period of time, probably the better option is the mineral-based, like the lighter ones, because they still cut good, they still cool better than really thick traditional oils. So they still cut better, cool better, but they're a little less maintenance required.
Yep, absolutely.
Okay, so we can talk about the plateau mode. We were doing this yesterday, and back to not removing too much material.
Right.
I think that was the real key, right?
Yes, that's the key. And so when you're developing a process, as we alluded to a little earlier in the presentation, is you're going to start with a base finish. And I'm going to lay that base finish down in the cylinder, but then I'm going to take a trace of that base finish before I ever go over it with a Plateau abrasive. And that base finish has to have the right RVK number. It has to be realistically 20 to 30 points higher than you're going to want in the end process. So if I want a 60 or a 50 to 60 RVK, I'm going to want to start out with anywhere from an 80 to 110 RVK. So when I plateau, I remove some of those, you know, some of the distance there is going to be removed and my RVK is going to come down. Now, there is a misconception, what a lot of fellas think is so if I go in there with my 600 grit over the top, if I continue to hone, my RPK value is going to change. It will not. Your RPK value is determined by that plateau grit size. So if I want a RPK value of say 10 to 12, I'm going to use a 600 grit abrasive. Yesterday, when we were doing some honing with the fellas here at RYR, they wanted a lower RPK number. So we ended up with a 1,000 grit or a 1,200 grit over the top of a the 180 grit. We started out yesterday and with a 325 grit diamond, and in these harder blocks, it would only give us an RVK number of 18. Well, we were wanting 30 plus. Well, you're never going to get there. So
time out, because I think most people, if they probably don't know this, if you take a traditional small block Chevy cast iron block and you hit it with a 325 grit, you are going to get 30 to 40
RVK.
Yeah.
Yes, sir.
Okay.
Yep.
So
there's that much difference.
Just in the block material.
Just in the block.
I think that's the key thing.
Yep.
I think we wanted to get across is that if you have the same abrasive, same speed, same load,
right,
4 different block materials, you are going to get 4 different surface finishes. Okay.
That's right. So you have to develop a plan for each different block material. And so that was what we did yesterday. In fact, we went one step farther. We went to a 270 grit, and that got us up into the high 20s, which was amazing. In a normal small block Chevy, you'll be in the 70 to 90 range on RVK with a 270 grit. And we actually had to drop down to the 180 grit to get our RVK numbers up high enough. And then started out, we switched to the Plateau stone, and I believe we hit it with, I think it was 8 strokes.
Yeah, then the first one was 6 with the 1200.
Yep.
And it came down, and then we went to 10.
Yep.
With the 1200 at 20% load, and then boom, it was
right there. And so that's what you'll do is we'll put that base finish in there. We'll throw our 600 or our 1200 again, depending on the RPK value you want. And we'll start out, I typically start out with 6 strokes, and then I'll check it. And if my RVK is a little high and my RK values are a little high, I don't typically go in over the top of that cylinder that I just plateaued. I'll go to a new cylinder that still has that rough finish in there, and I'll add 4 strokes or 5 strokes, whatever I think it's going to need to get where we want to get, where our RPK is the right value, our RK values are right, and our RVK value is the right.
So one thing about the H85, not to sound like a commercial here, but I thought this was really cool, that when you went to the plateau mode, that the stones or the abrasives are actually fed out and the coolant starts to flow before it begins to rotate and stroke.
It's super critical. Again, when we talk about microns and how little material we're taking off a cylinder wall in the plateau mode, if my honing machine begins to spin at the top of the cylinder as I'm feeding the stones out, I'm eliminating my peaks and I'm eliminating my valleys. And so you'll end up with 2 different finishes in a cylinder, and it's very inconsistent. So when you're in the plateau mode, you really want the abrasives to be against the cylinder wall at the pressure you determine, and then begin the stroking process along with the rotation process. It's simultaneous. Any excess spinning, even just 3 or 4 revolutions at the top of the cylinder, is going to give you a different surface finish at the top of the cylinder than it will at the bottom of the cylinder. So it's really critical when we're plateauing to feed our diamonds out against the cylinder wall and start the process, both rotation and stroke wise.
Yeah, we used our buddy Bragg Lagman's little profilometer holding tool, and we checked it. Top of the bore, middle of the bore, and the bottom of the bore, and they were very consistent numbers.
Very consistent numbers. Yeah, and a shout out to Brad for that little tool that he gave to Lake.
Yeah, it was awesome.
Yeah.
So we'll kind of wrap it up. We kind of talked through a lot of this. Is that that base finish, you have to have in mind what we want to achieve to choose your proper abrasive to get that base finish, so there is enough valley so that when you go to plateau it, there's still enough valley left to be able to do that. And then I know Keith mentioned it and you mentioned it, and I put it in bold because to me it's the thing to kind of summarize it. RPK is what the rings see, and RVK is what the oil sees, and you need to have both of those things happy. happy ring, happy oil, you're going to get good ring seal. My analogy is ring seal is soup. It's not a steak dinner. It's not a steak, a potato, and a side. It's soup. It's broth and veggies and meat and spices, and you got to cook it all together. And for some applications, you may need clam chowder.
Right.
Something else, you might need chicken noodle soup.
Yep.
It depends upon the applications, what that soup needs to be, but nonetheless, it's always going to be a soup.
That's right. Yep.
Anything else on these pages you think we need to kind of touch on?
No, I think we've touched on most of that. Again, the RPK value, the RPK values are going to be determined by your grit on your plateauing mode. So be it a 600 grit or an 800 grit or 1,000 or a 1,200. Now, I don't want to scare people and think you need all of those, because typically, if you look back at the parameters that Keith and Blake have talked about, and I think Keith even alluded to that, the RPK value doesn't change a whole bunch for the different applications. So the 600 grit is what I have found is the most optimum. If you had to buy one grit to plateau with, it would be the 600 grit, in my opinion.
Yep, perfect. So basically, we just said those same things.
Well, if you don't mind, I want to throw a couple things in real quick.
Sure.
Well, just to back up what Ed was saying, and from my side of it, being a person that talks to a lot of people, fields a lot of phone calls every day. If I had to say there's one thing that a lot of guys miss, is they simply don't have, whenever they equip their setup, whether it be with vitrifieds or with diamonds, whenever they equip their equipment, whoever sold it to them, wherever they bought it, whatever shop they bought, they simply don't have that stone, that 180. You've got to have that aggressive stone to lay in that base. And 90% of what I see wrong in bore finishes, they simply didn't lay that base in. They didn't get that number. I think Ed will probably concur with me. And then they come in, start plateauing, and they've just wiped everything out. As Ed said, the RPK number, that's a reflection of the grit of the stone you use to plateau with. If you want to get an RPK here, there's going to be a grit number that's going to get you. You can, if your RVK and RK are still sitting too high, don't be afraid of it. It's not going to drop the peak, because that is a reflection of that abrasive grit. Give it another stroke. Creep up on it. Don't, as was said earlier, don't wait till you're all said and done to start taking these measurements. You want to work your way along the line. Take a measurement when you've got its size. See where your valley's at. As stated, if your valley's not sitting at 100, 110, there's no way you're going to end up at an RVK over a 50 or 60 when it's all said and done, and have the right peak and core. Another thing to remember is going around the block. Once you're establishing processes right now, you're establishing methodology. How do I do this on this block? And that pretty much will get you there, but you still need to check them. Don't forget not to do it, because even around that same block, they're going to be different. One hole might take 2 more strokes on the plateau. It may take 3 more strokes on this hole. The blocks will range in hardness front to back and around the block. So you do run into those differences as well. So don't be afraid to kind of check more than a few cylinders.
Good point.
Yeah, absolutely, Keith. Great point. And that just sparked another thought from me, is when we're talking about that 180 grit, that is a diamond grit. Diamond grit and vitrified abrasives do not leave the same surface finish. So please, anyone that's using vitrified abrasives, that 180 is not going to get you that RVK value that you need. You're going to be down on a vitrified abrasive. You're going to be down in the 80 grit range or the 120 grit range in order to get enough RVK to maintain those valleys that you need to maintain.
That's great. Great to know that the different type of abrasive,
yes,
even the same grit will also yield a different valley profile. Okay.
Diamond is so much harder. It's not it's not as friable as they say. So it doesn't fracture like a vitrified abrasive will. So
okay, great to know. So if you're interested in all of this kind of information, you need to sign up for free for the Engine Performance Expo in January, because both Keith and Ed will be doing a demonstration, a longer form talk, more detailed than even we were able to do today, as well as have both some recorded and some live video actually demonstrating these things we just discussed today. So you can sign up for free today, engineperformanceexpo.com. It's going to be fantastic. Since we don't have a PRI this year, we get to have this instead. And with that, question time.
I've said this before, but wow, I'll tell you, my mind is spinning. And questions, boy, do we have questions. First one from Brendan, is RK the most important measurement or RA? Brendan, I think that's been pretty well answered. If not to your satisfaction, please add in another comment. Derek is asking, where can I purchase this measuring tool to check the cylinder wall?
Well, you can call Total Seal. We have the Meditoyos for sale. You can call us and we can get one for you.
Yeah, let me answer that. I don't have any skin in the game there. I will tell you that the best source I have found in the automotive industry is Total Seal. Those fellas, as far as price points go, you can't beat them, and they set them up for you because there are parameters in there that you can change. And Keith or Lake or any of the other guys at Total Seal, they'll set those up for you to where you take it out of the box, charge your battery, and you're good to go.
Yep.
Great. Dennis is asking, how does one chart the piston ring material makeup to the finish required? Will the ring manufacturer share their material makeup?
Keith?
Yeah, I'll kind of grab onto that. Yeah, absolutely. We'll give you whatever kind of data you want to have. And when it comes to that, we can talk about the ring base material, kind of like talking about the bore finish. You've got the base material, what the ring is actually made out of, that material, but then we have to look at the coating. What is the coating that's going to run against the bore? That's really the thing. How, is it a 85 pound of boost, E85 engine where we've got tons of fuel trying to kill the oil film, and titanium coatings? So yeah, we would gladly share you all that information. And once we know a little bit more about the specific application, what kind of block, what you're working with, then we can, we'll gladly give you the numbers of where we think you need to be, or at least a good starting point, because there's so many little details and so many variables involved with this. You can take a simple question like I mentioned the other day, just, what do I need to do? Well, we need more information. What's the fuel? How much boost? What kind of block? And then we can really deep dive it and give you the information you need.
Exactly.
Okay, Dennis is asking again, dealing with multiple engines from gasoline to diesel, the material makeup of the cylinder block is usually matched to the piston ring supplied by that manufacturer. Does that mean we should measure surface finish in the block before we start to rebore and finish?
Well, it's kind of really, it's what you want to do is look at the finish when you're done. Again, you want to reach out to us about, what is the application? Diesel, gasoline. Are we talking just rebuild diesel stuff, or we're talking performance diesel stuff? And we can help to give you that information of where it needs to be. A typical diesel application, we're going to shoot for higher RVK numbers. So it's really, from an OE point of view, the block's not tailored to the rings are tailored to the block. So they're going to come to whoever the OE manufacturer is, talk about, material longevity, how long do they expect this engine to run, what's considered acceptable oil consumption. They're going to lay those parameters out, and in some cases have to make adjustments once it's out in the field and running and finding, well, that's not what is happening. So we may make adjustments to the coatings, adjustments to oil ring tensions. But from a finishing point of view, no, it's really a matter of, reach out to myself or Lake or Kevin or Bobby, right? Any of the people here with what your application is, just drop us an email, give us a call, and we'll give you some parameters to shoot for. And then, once you've bored it, honed it, you want to shoot for those numbers.
In fairness, I think that you can contact any of your ring suppliers for that kind of information as well. But certainly Keith is well versed in this and understands it. Next question from David.
Yeah.
Would you hone different RVK, RPK values on the cylinder wall by location, upper/lower parts, or do you make it uniform through the whole cylinder? Ed, I think you answered this earlier, but do you have anything else to expand on that?
Well, that's a great question, because again, talking to Mr. Jones as much as I do, Keith, and Keith alluded to me at one time that there is a possibility that, they may want different surface finishes in different portions of the cylinder wall. And so you want a higher RVK number at the top of the cylinder where all your pressures are at versus a lower RVK number at the bottom of the cylinder. And not to be an advertisement, but with the Rottler machine and the software that we have, we can actually generate two different finishes in the cylinder wall or in the length of the cylinder for you. I personally don't know if that's important or not. Keith could elaborate much better than I could there. But as far as being able to do that, yes, you could with one of the H85 series honing machines.
Yeah, and what Ed said, yeah, I have seen, you know, if you want to use the word, the ultra high end or the uber high end of racing engines that do actually run that multiple pattern. They've got a different finish, different oil retention RVKs in the top of the bore versus the bottom of the bore. They're trying to reduce as much drag, as much friction from, you know, the stiction of the oil on the bore, trying to, again, push that oil back down to the pan. If we can, you know, if we don't need as much oil retained on the bottom portion of the cylinders, we're going to be able to get that oil back down more easily and push it off the bore more easily than, you know, more oil on that bore. So yeah, there are applications where that does apply. And I think over time, as the OE worlds, you know, are constantly striving for, you know, better fuel efficiency and dropping tensions the way they are. I mean, some of the ring tensions in some of these OE engines today, you know, they'll blow your mind if you saw how thin and how lightweight some of these parts are in stock engines today. I think you're going to see more and more of that type of honing happening throughout the industry.
Okay, David expands on questions with are RVK, RPK numbers different depending on engine cylinder location, such as the flat 6, the straight 6, or V6?
Keith, that's up your alley.
Okay, I was going to say which one of us wants to grab onto that. Again, really not so much as far as it being a flat engine versus a V engine versus an inline. Again, we come back to getting oil retention, how much fuel's going through it, how hot the cylinder runs. There are engines that I work with that have what I'll call inherent temperature issues because of coolant circulation. They don't move the coolant around particular cylinders in the block as well as they do others. And what we have found for a solution in those is we had to increase the RVK number. We had to get more cooling effect from the oil because we couldn't get it from coolant without re-engineering the block. So that was is a case of why are we having this issue in these cylinders? And it's always these cylinders. Well, once we started really deep diving and looking at this thing and started looking at how the coolant's moving throughout the block, it's starving these cylinders. And the solution was changing, in that case, again, outside of redesigning the block and the cooling system, was getting a different RVK value, increasing the oil retention to try to create more cooling effect through the oil.
Our next question is from Juan. Can you talk about the characteristics of the cylinder finish, hone and material, required for extremely hard materials, for example, diamond-like carbon-coated rings?
Well, DLCs, again, we're back to finding the right finish for the amount of oil retention that it needs to have. We don't really do much different for DLCs than I would say for another hard coating like a titanium. As far as in an iron style bore, DLCs, engines that typically run DLCs, not all but many, do run on, and we didn't touch on this at all during the presentation, on some fairly exotic coatings on the bores. Some of them will run on Nikosils. Some of them will run on Alusil, aluminum silicated, silicon impregnated aluminum. Try to get that out 5 times fast. Some of them actually run on DLC coated bores. They're running DLC against DLC. So the finish characteristics change quite a bit. But as far as like DLCs on an iron board, no, we really don't do anything dramatically different there.
Okay, Juan is also asking what kind of engine break-in procedure would be required to seat the ring liner interface. I assume he's referring back again to these hard rings.
I'll actually kind of let Lake jump onto that one. He did a real nice deal on break-in procedures, and it really is an extremely important subject.
Yeah, so if you go to anybody that's listening that really wants to know without going into the long discussion so we can get to more questions, go to our YouTube channel. So if you just go to YouTube, type in Total Seal Piston Rings, go to our YouTube channel. There's a video that myself and Don McCaskill from Shaver Specialty Racing Engines did, going through a break-in process and talking about how you got to have the right break-in oil, and then you have to have the right amount of heat and load applied to the motor during that process to ensure proper ring break-in. And that was all being done with, alcohol fueled engines with very high, hardness rings, titanium nitride rings. So that process works for everything. So if you get the process is part of that recipe back to that ring seal soup. So YouTube, Total Seal Piston Rings, check it out. Subscribe while you're there. It's worth your time. So next question.
From Brendan. Have you ever used any of the laser etched finishes for the top of the cylinder that holds more oil?
No. Straightforward answer.
Okay.
I've read about it in magazines. About it.
That's as far as I've gotten.
I've watched the videos. Yeah, I think we've all watched the videos and go, "Wow, that's really cool." But never seen it in real life.
Okay, moving on. From Jim, any general comments on how a two-stroke engine may differ in ring bore finish requirements?
Well, my dad is two-stroke guy. He started off racing go-karts. Me and him still do vintage karting stuff, and that is a topic that me and him have talked about a lot in terms of what we want to try to utilize the profilometer, begin to measure the finishes and stuff, because a lot of that they just kind of done what they've always done, which goes back to having valleys enough to hold the oil fuel mixture, because obviously with the fuel is the oil delivery device in a two-cycle, so you have to have enough valley on the finish in order to retain it, to be able to provide that lubrication for the ring. And then back to the plateauing, with those headland rings and a lot of those engines and the amount of tension they run, it is certainly plateauing while it runs. I mean, there's no doubt that with those old engines, the way we own them and do them, we are breaking in the engine, and we go through a pretty lengthy break-in process to ensure they do seat in. So I don't have any firm numbers for you, because Ed may be able to have that, but I know we do it when we go through a very thoughtful process of leaving a fairly rough finish so we have valley, and then go through essentially plateauing it in situ on the racetrack before we actually really start running them for that very reason.
Actually, the only thing that I would add, and I think Keith will back us up here, is it depends. A lot of two-cycle stuff is now coated. It's Nikasil coated, or there's a new coating out, I think, that Honda uses, and like on a Nikasil coating or a chrome coating, it's a very porous system, or it's a very porous process. So you really don't have to have plateau finishes on those type of surfaces, because there's so much porosity there, it holds the oil for you. Now, the only caution I would make is especially on Nikasil, because it's such a hard material, that you want a very fine finish on that so you don't chew your rings up. That would be probably the biggest caveat that I would offer.
Okay, from Carl, what about air cooled?
And I want to agree with it. Yeah, I'm sorry, let me just, and I agree with that completely. You've got to watch Nikasil. One of the things I wanted to touch on just really quick, we're really diving into the two-stroke stuff as of late, between Lake and ourselves, working with some of these two-strokes. The beautiful thing is Lake and his father, they've got the engines, they've got a dyno. So we're really kind of diving into two-stroke stuff. So keep an eye out. I don't want to sound like a commercial, but we're playing with some gas-ported rings, and we're playing with finishes, we're playing with coatings, stuff that we've really never really done a lot with on two-strokes in the past. So I think we're going to have some pretty cool things in the two-stroke world coming up relatively soon.
Okay, from Carl, what about air-cooled Harley-Davidson cylinders?
Same thing there. Yeah, go ahead.
No, well, I was just going to say, Lake and I were having a discussion about this very thing last night at dinner, and as Lake was talking about, typically you're wanting surface finish wise. I don't know if there's a big difference, but what you might want to change is your crosshatch angle on an air cooled engine versus a Lake, and you may want to.
Well, back to, I know we've had a lot of conversations about crosshatch angle, and it's what helps ring rotate. When you have those very long stroke engines, which a lot of those are. You need to have that more included angle in order to have proper ring rotation. Yeah, steeper angle to make that happen. And I know Keith deals with these guys, and he's by far the expert to talk, not me.
Yep. Take it away, Mr. Jones.
Well, what you run into is, in some engines, it's funny. We all have worked with, the quote unquote 45-degree crosshatch angle. That's the angle. Well, that's what's referred to as the included angle. I don't have any way to draw that out, but if you're measuring it simply off the deck, off the horizontal axis, your number's half that. So a 45-degree, of course, is 22.5 degrees measured off the deck. Harleys typically run about a 60-degree crosshatch angle, so about 30 degrees, a more vertical, more up and down angle. And what that's doing is it's allowing oil to move up and down the bore more easily. The flatter the crosshatch angle, the more the oil wants to move left to right versus up to down. Blow-by, flatter angles help to eliminate blow-by from getting past the rings, but you do get to a point where that angle becomes so flat, it acts like, like driving over railroad tracks. You start to get a chatter, and it's defeating. So you'll play with the angles, how much blow-by the engine wants and how easy is it to move the oil up and down the bore. Flat engines, Subarus typically run a 60-degree crosshatch angle. And this is, again, to help promote getting oil back into the sump and get it out of that bottom of the cylinder so they're not puddling. So the answer on the Harley is, one is to pay attention to the crosshatch angles. They typically run a more vertical angle than a comparative V8 engine. One of the things that I run into with Harleys is, and we go back to what Lake talked about, the break-in process. I get this, and I don't know where this ever came from, but I get this said to me all the time about how you break in a Harley. And it's you fire up and you let it get hot, and you let it idle for 5 minutes, and then you let it cool down. And then once it gets down to, 50 degrees, you fire it back up and you let it sit there and idle, and you do that, 7 times. Or if the first new moon comes up first, there's this whole, I'll call it, system of how you break a Harley. And I've never understood that. The last thing you want to do is have an engine sitting there for an extended period of time in an unloaded condition. It's not burning the fuel going through it. We're breaking that oil film down, which is so critical during initial run-in times, that air-fuel ratios be right, fuel curves be right. Fat is not a good thing during run-in. And the bottom line is, get it out, get a load on it. I'm not telling you to go out there and beat the thing to death, but once the timing's set, you got the valve set, it's not leaking, it's not doing anything stupid, get it out and ride it. It's the best thing for it.
That kind of leads right into a next question from ATEC, and is, what is the preferable crosshatch angle on cylinders? This does not refer to Harley-Davidson, it's in general.
Yeah. Again, I'll jump in. Most engines, 90% of 90% are going to have that typical 45-degree crosshatch angle. As we get into bigger bore, shorter stroke, higher RPM applications, we find that flattening that angle out down into, we'll say, mid to lower 30s. Some people even play with them into the high 20s. As far as included angles go, again, we're getting less blow by. We're able to hold oil better, more vacuum. One of the things that we didn't touch on, but I will quickly, you get into very high RPM, big vacuum engines, and that RVK number and crosshatch angle becomes so critical to keeping that oil on the bore. We're dealing with 20 plus inches of vacuum in a bottom end, trying to suck all that lubricant back off, and very, very lightweight oils today, 0.05s, 015s. We're dealing with oils that move very easily and are sucked right back down to the sump. It's easy to dry the parts out. So, you get into those high RPM, short stroke, big vacuum applications, and that flatter crosshatch angle, most people I know run them in the 30s, 32 to 36 degree is pretty typical, but very important to get that valley number. So, what oil is there has got something, some ability to hang on to that bore.
Okay, ATIC has another question, that is the lower the RK, the smoother the finish?
What was that? The lower the RK, the smoother the finish.
Is a lower RK a smoother finish?
There's less core roughness, but that doesn't mean it's necessarily a smoother finish.
It's only one part of the. It's only one part of the puzzle, though. You have to look at all three of those values, really, right? Mm-hmm. Okay. All right. Let's move on.
You just nailed it. Just like Lake said, it's part of the soup. If you lower the RK number down, part of the finish is smoother. If you're simply looking at RA numbers, it may not affect it that dramatically. It depends on how far you get the ratios off.
Okay, let's move on. From Brandon, how many strokes and what kind of pressure with the CBN? What kind of refractometer reading with your coolant?
So every coolant will have a different concentration level depending on the brand or the manufacturer. Our particular coolant that we recommend, we have a 20% concentration level. So on our refractometer that we sell with our machines, it's a 3 to 5 number on our refractometer. On the strokes for CBN, we're really back to the same thing. It's so hard to just lay do this, and this without knowing what the engine application is and what type of block it is and those sort of things. But as a rule, we start out, and again, it will depend on what base finish you have. If you're using a 325 grit or a 180 grit, the 180 grit really gives you a little bit of leeway, so to speak, so you can start out and do 6 strokes and see where you're at. If you're using a 325 grit and you're trying to get, let's just say, an RVK in the high 20s, if you do 4 strokes, you're probably going to wipe it out. So that's an excellent question, but it's really hard to answer that unless they're very application specific, I guess.
That leads right into Ted's question. When you count strokes, is one up and one down counted as one stroke, or is up one stroke and down another?
We count it up and down as one stroke.
Makes sense to me. From Benjamin, ball hone or whisker hone for final finish process?
Neither. And Keith had brought up a good point earlier, in that you're trying to get the proper finish. We're trying to get the proper area for the rings, and we're trying to get the proper area for the oil. Once you obtain those, and you're at the track, and you need I don't know, you're down on power or something, you decide, man, we got to change the rings. You can go in there with either one of those and hone a few strokes and put it back together. But Keith, you probably should allude on that or comment on that more than I.
Yeah. There's when it comes to the honing process, like I said, what I'll call the at-track service. There's guys out there. I'll tell them, hey, throw a 240 ball hone through it. I generally don't recommend them to go by the 3-finger KD spring-loaded hone from the Napa shop, because that's what I want to call an uncontrolled result. You have no idea what it's going to be like. The ball hone's relatively not obtrusive. It's not going to try to change the bore geometry. It's going to just kind of clean the surface on the top and get whatever kind of nastiness might be on there, or lack of any kind of finish because they wiped it out. So it's a good at-track service tool. They work they do what they're supposed to do. They'll come back in there, freshen that bore up, clean it up. If you're really in the machine, doing what you do is as Ed does with, honing in the shop. Now you want to come in. I love the finish that CBN puts on there. That large jump from 180 to 600, 500, whatever it takes to get that peak value that you want. That's really the way. Can it be done with a ball hone or a whisker hone? Yeah, it can be done. There's probably 5 different ways to do it, but there's the right way, the easy way, the correct way. And as Ed described, I do like coming in with a very aggressive stone, then a fine stone, light pressure, check it as you go. But the ball hone will do a service. Again, not to keep burning up too much time, but there's the illusion that it's going to come in and restore that valley. Very good friend of mine locally here in town, super gas car, 500 passes on it. Calls me up, he's ringed the engine, all kinds of problems, this going on, that going on. And, go over to his house. He's got the thing apart. I knew it had a little over 500 passes on it. And my comment to him was, how you honed it? And well, he's got his cordless drill motor with a dingle ball hone on the end of it. It's like, no, this is the whole, he did not quote unquote hone the bore. He might have cleaned the surface up, put some scratches in it, but there was no valley. Engine came out, took it to a local shop. They ran it through the hone, put it back in, bang, everything's fine.
Okay, need to move along. We're starting to lose a lot of people, so and we haven't even hit, looks like, about half our questions. So I'd urge you to kind of limit your answers. Give what you need to do to
we'll put it on turbo mode.
but don't expand exponentially, please. Okay, from William, what is the best oil for both vitrified and diamond stones?
Mineral based.
Yeah, that's what he's asking. What is the best mineral oil? Oh, you're just saying a mineral base?
It has to be with standard abrasives. They don't tolerate water-based coolants.
Okay, that's pretty specific. Robert is saying, awesome presentation, very informative. Question though, how does the crosshatch angle relate to the various surface finishes? Is it constant or does it need to change for a specific application? I think you guys kind of addressed that, but do you have anything else to add?
Nope.
Yeah, no, the crosshatch angle again comes back to ring rotation speeds and blow by numbers. I don't really change bore finishes based on crosshatch angles. So,
okay, from John. So it sounds like you feel that there are too many steps involved to get the final finish, or put another way, to arrive at the correct RA, RZ, RVK. What I'm saying is taking a 270 diamond closer to final size before switching to a finer diamond. This to retain the deeper valleys needed at a finished size for a gas engine.
So yes. if you're really wanting plateau finish, you're actually going right to size. You're not leaving an extra tenth or two in there. You're going right to final size, and then you're using your CBN for, again, depending on application, 6 strokes, 8 strokes, 10 strokes. Some of the applications I've got into to where we have to put 20 strokes on there. There you might see a tenth or at the very most 2/10 enlargement of the bore. But as a rule, we go directly to size. I think that's what he was asking.
Yeah, I think that's pretty much it. Yeah, how much you don't want to go too far is what you're saying. Otherwise you'll eliminate the peaks.
Yes.
Okay. All right, from William, he's adding a comment. One more important aspect, again, we're going back to crosshatch, it looks like. One more important aspect is the angle of the hatch, like rifling in a barrel. He uses 1.5 turns per 6 inches, saying that the root needs to complete the exit for the oil to reduce hydrodynamic lock.
Okay.
You drew a blank on that one.
You kind of stumped him. I would suggest you get in touch with Ed or Keith directly on that to get a better explanation of what you're after or what your comment is. Okay. Carl is just simply asking,
yes,
what grit is used to start? Again, that's been beat up pretty good, I believe, based upon what your needs are to
An
on the
RVK.
application and
Yep.
on the material of the block.
Yep.
From Ansel, please explain the importance of an accurate crosshatch pattern on bore finish. Again, I think we beat that up pretty good, don't you?
Mm-hmm. Yeah, the new hones give you an accurate crosshatch throughout the bore.
What was that, Ed?
I said the new hone with the ball screws for stroking gives you an accurate crosshatch throughout the bore. There is no flattening of the crosshatch angle on either end as the machine changes directions.
Very good.
Just to jump on that real quick, Ed and I were just talking about this the other day. You can, depending on the kind of machinery you're running, end up with multiple crosshatch patterns laid over top of each other. Rough honed it at this stroke and rotating speed, sized it at this speed, dwelled at the bottom and just let it sit there for a while, creating a completely flat pattern. You want to try to avoid this at all costs, because that can really play havoc with ring seal and oil control. You want to try to get that nice consistent pattern top to bottom. Real important.
Makes sense. From Jack, should bore or block hardness be tested, and will hardness influence our honing abrasive selection?
Yes.
Yes.
All
Very
three,
good.
yes.
Pretty clear. From Matt, does a softer block, say a 160 Bernal, need more RVK and less RPK so as not to put too much iron in the oil? Also, does a methanol application need to be closer to a diesel because of the amount of liquid? Thanks, guys. You want me to break that down?
I guess I'll kind of take that one. You just, with a soft block like that and a fuel where we're trying to wash all the lubrication away. Yeah, you may want to start with a little higher RVK number, getting it up into maybe into the 60, 70, 65, in that range. Again, that kind of number kind of talks back to longevity. And if we're dealing with a soft block in an environment that's going to have, say, a lot of dirt going through it, like a sprint car engine or a dirt late model that may not have the best filter, and a lot of fuel going through it, it kind of speaks to longevity. If we start off with a finish that's really pretty smooth, remembering rings are always going to wear the bore. That's always what they're going to do. That it's never going to go the other way. If we start off with a little bit more aggressive finish in that kind of an application, one can expect a little more longevity out of the engine.
Well said.
Next question from the Alberta Clipper. Will a lighter tension oil ring benefit from a higher RVK number and make more horsepower on a naturally aspirated engine application?
Keith, that's up your alley.
Yeah, again, it's one of those, kind of like Ed said, and we talked about earlier. It depends on the specifics of the environment. If we're dealing with a high vacuum environment with that light oil ring where we're trying to really pull all the oil away from the bore, then yeah, that ring's going to want, you want it light drag to keep the friction out. But if we've got that vacuum source in there trying to wick all the oil away from all the parts, then we're going to have to, to force that oil to retain itself on the wall through increased RVK. If we're just dealing with an everyday NA piece, no vacuum, no anything, we generally reduce that valley number a little bit as the oil ring tensions drop. We're not, we're not removing as much oil off the bore. A 4-pound oil ring's not scraping anywhere as near as hard as a 20-pound oil ring. So we're able to bring those numbers down because we're not, getting rid of as much oil through the scraping effort. We're going to leave a little more oil on the bore because of the lightness of the ring.
Great. From Damien, do these rules apply with cylinder nickel coated?
Nicosil,
I assume that's what it is.
Talking about Nicosil. And I'm not sure which rules on the Nicosil stuff. I think we talked about that pretty well, but you want a very fine finish on the Nicosil so it doesn't eat the rings up. But the characteristics of Nicosil is it's a very porous substance, so you don't need deep. You don't even try to put a big RVK in it because it's has so much porosity it holds the oil.
Okay,
I'll touch on that one real quick. Nicosil is one of those things. It's kind of as Ed said, it's a whole different beast. There's that product. There's Sumibor. There's the arc plasma sprayed coatings that do hold oil. Generally speaking, and this is probably the only time you'll ever hear me say this. You're generally looking at RA numbers on that surface. We're typically looking for an RA between a 4 and an 8 because we want to make sure that we don't have a real aggressive tooth that's going to chew the rings up. So it's one of the few times we'll actually talk about RA on cylinder finish is looking at Nicosil. A rough Nicosil will destroy a set of rings on startup.
Okay, from Justin. RPK is influenced by Plateau abrasive grit, not number of strokes, you say. RVK is influenced not only by grit, but also stone pressure, as well as the number of Plateau strokes. How does one influence the RK, or bearing surface, of the cylinder wall?
Oh, the RK value is, and Keith and I have discussed this, I usually tell the customers that I deal with that RK is along for the ride. When you determine what RVK you want and then what RPK you want, I kind of let the RK settle out. Now, if you're very specific and let's say you want a very deep scratch but you want your RK values to be somewhat lower than would normally occur, you'll have to go in there with a secondary roughing up, I'll call it. So you'll go in with a 180 grit, and you may follow that with a 400 grit only for a few strokes. It's not, you can't remove a half a thousandths of material with that 400 and expect to maintain your RVK numbers. It's 4 to 6 strokes and then go over the top of that with the 600 grit. That's how you would reduce your RK numbers.
Very good. Corey is asking.
I just want to touch on that. I'm in agreement with, yeah. Oh, no, go ahead. Go ahead.
Corey is asking, are there finished numbers you look for after you run or dyno an engine?
They're going to be smoother.
Yeah, no, I'll touch on that. Yeah. No, go ahead, Lake.
I was going to say, yeah, they're going to be smoother, man. That's because, like Keith was saying, the ring is going to be plateauing. So a lot of what we're giving you are the targets to start with, knowing that they're going to back up from there. The ring is going to do its job, and during that break-in process with your break-in oil and doing all those things, those numbers are going to come down, and they should, based on our experience, land where they need to be long-term. And you can check them when the engines come back in, especially if the engine's in good health and everything's running good. That's a great time to check what your operating values are, and that's good information to have, kind of like checking your free gap. A whole different conversation there, not trying to go there, but it's good to know where you started. It's good to know where you end, so you have that full range of information.
Next question.
Just to hit with Lake real quick. What he said is exactly it. It's a great telltale. Look at that number when the engine comes apart, knowing what it was and what it is. It'll tell you if something odd's going on. Just very quick, I've got a guy down in Australia. They got 15 poles on a motor. They're having problems. He sent me the rings to look at. These things, there's not a single wear mark on these. They look like they're brand new out of the bag. His numbers haven't moved a bit. What do you have in this thing for oil? Because it's incredible. So looking at those numbers can tell you a lot about what the engine's doing.
Okay, Carlo is asking, what do you recommend for us guys that are still using vitrified stones, 4, 5, or 2-step? Most of the engines we build are naturally aspirated street strip apps. They need to get lots of mileage from them. Thank you.
Keith, do you want to handle that one, or?
Well, I think I'm probably going to be in agreement with Ed. I mean, vitrified stone versus diamond stone. I mean, the cause and effect of what we're trying to do is still the same. I have guys, as Ed was saying about, that use a vitrified stone to get that valley number, and they've got to go in with something aggressive, get that number in. Then they may come back in with a 400 grit stone to knock it down. It's still kind of the same process. So I'm generally 2 steps, 3 at the very most. but the more steps you put into the process, the likelihood of something going south it's exponential. It just becomes so much bigger. So I like 2 steps, 3 at the very most.
You agree, Ed?
Yes, absolutely. Total agreement.
Okay, from Bill. Where can you go either virtually or in person to observe or get hands-on training on how to use the profilometer? Great webinar. Well done, guys. Take a bow.
We're actually going to do a demonstration during the Engine Performance Expo. So sign up for the Engine Performance Expo and you can do your training right there for free.
There you go. My suspicion is if you also check out YouTube, you will probably find dozens of videos on profilometers. Okay. I'm going to really hash this name up, and I apologize. Janur, what is the minimum and maximum bore possible to finish accurately, or accuracy percent? What is the minimum and maximum bore possible to finish? I am not sure what you're asking. Do you guys follow?
No, I'm not either. I mean, as far as maybe he's talking about accuracy of the cylinder bore or whatever, but you know, typically with the new style hones that are being manufactured today, I mean, it's absolutely, you know, it's a no-brainer to be within 2/10 of size and straightness in every single bore. And with a little effort, you can get closer than that. But I mean, just pushing a button and walking away, you're going to be within a couple of tenths of bore size and straightness.
Okay, if that isn't quite on target, please add another question for us, Janur. All right, Adam is asking, when checking cylinder finish with the profilometer, does the honing coolant need to be cleaned from the cylinder wall first?
Yes. Absolutely.
That's a Big 10-4, good buddy.
Yeah,
okay.
We're back to that same thing. If you think about what a micron is, and even a speck of dust or anything will give you what I call an anomaly on your reading on a profilometer, and you'll see it on the screen.
Okay, I think Majnor already has clarified this. With the next question is he's talking about maximum bore depths. I guess the length of the cylinder.
I'm still confused, sorry.
Yeah.
Okay.
Sorry.
All right. From Martin. On our race engines, we quite often tear down the engines for maintenance. We had quite experience of using honing brushes to get the RVK up again a little bit. What is your point of view on the use of this technique?
I think we pretty much addressed that, haven't we? Keith, you did a good job of that a little bit earlier.
I'd say so, for sure. From Sean.
Yeah, I think so. I mean, it's you know, give it a touch up. You got to give it as we call it, give it a little puff hone and, you know, bring the numbers back.
Yep.
Okay, from Sean. Using vitrified stones, what do you suggest is the best sequence of stones to obtain the best RVK RA for circle track engines using an 043 gas nitrided top ring? Webinar was great. I'm going to get an early Christmas gift in getting a profilometer. Way to go, Sean.
Awesome. Keith, you'd have to say what RVK numbers and RVK numbers you want, and then I could probably lend a little bit of advice there as far as grit sizes go.
Well, sure, yeah. A ring of that nature in that kind of environment, we're kind of back to what we were talking, our general thing. You're going to be PK numbers, 10 to 15 in that range. You're going to look for RK numbers, 40s to 50s, and valley numbers in the 50 to 60 range. And keep in mind, folks, these are windows. If you're a little bit over, a little bit under, if the RK is maybe a little higher than the VK, the rings are going to fix that. They're going to take care of that on their own. These are general guidelines kind of windows. We want to be in and around these numbers. If you're off a little one way or the other, hey, no heartache.
Excellent point. And the other thing you want to do when you're using a profilometer is take more than one reading in a cylinder.
Yes.
I tend to take 3 to 6 readings and average them, because those, again, we're talking microns. We're talking minute particles that will affect your readings. As far as standard abrasives or vitrified abrasives, you're going to be realistically, I suspect, to get an RVK in the 50 to 60 range, you're going to be in the 80 to 80, 100, 120 grit, depending on the Brunel of the block. If it's a really hard block, you may not be able to get there. And then to get your RPK values down, you could probably get by with a 400 grit for a few strokes over the top, because again the vitrified abrasives give you a 400 grit vitrified versus a 400 grit CBN or diamond will give you a much smoother finish than those two will, because the grit is friable. In other words, it fractures as the honing process takes place.
Okay, I'm not sure we touched on this next question on Harleys. This one's from Dan. What would you recommend for an RVK and RPK in an air-cooled Harley? With steel liners, I might add.
Keith?
Well, I would say, one, they're probably not steel. I mean, truly steel liners are pretty rare. That's about the only time I've seen engines that actually have, honest to goodness steel liners are generally aircraft engines, and they're usually a nitrided steel, and they're, over 500 Brunel generally. And I can't say that he doesn't, because I don't know what he has, but usually they're a ductile iron sleeve. So again, kind of similar numbers that we just talked about. I would probably bring the VK and the RK numbers down a little bit, maybe bring them down about 5 to 10 points from what we were just discussing. PK numbers about the same, but I bring the other numbers down about 5 to 10 points.
From Mark, does the viscosity or weight of the oil people run have any bearing on the finish that you would put on the cylinder?
I think that one might be up Mr. Speed's alley.
Have we lost Ed and Lake?
Bueller.
I think we have lost Lake and Ed at this
point.
It's their screen is frozen.
I think we've locked up. To answer that question, generally no. I mean, again, as I lighten viscosities up based on, again, we go back to specifics of the application. If it's a high vacuum engine with running 0.8, 0.5, I'm going to look at that RVK number and try to bring that RVK number up, because I need more oil trapping. I've got to give that real light oil something to grab a hold of versus, say, a 2050. That 2050 is going to be much more viscous. It's going to want to stay where you put it, so I can bring that. I don't have to have as much valley number in that vacuum situation. So again, it kind of comes down to the specifics of the environment.
Okay. Apparently we have totally lost Lake and Ed. So we have a few more questions I'll throw at you, Keith, and then we'll wrap this up. We're starting to really lose a lot of people. What role does crosshatch?
Okay.
What role does crosshatch angle play with RVK? For example, if I need to run a shallow angle, do I need a higher RVK to keep the oil in the top of the cylinder, or especially in long cylinder like a 5.9 Cummins?
Generally not. The valley number, again, depending on the crosshatch angle within normal reasons, I don't really vary it. A real long cylinder like a diesel, many of those do run a 60-degree crosshatch angle. Real, long bore, long stroke, so they'll typically run a more vertical crosshatch angle. But no, we don't really vary the RVK number. Again, diesels like a bigger valley number. We're putting more fuel through there. We're dealing with. Again, all this depends on the specific environment. DI engine, where it's kind of more sooty, a little nastier environment. We're again going to want more RVK as compared to, say, a gasoline engine due to the fuel more so than than the operating conditions. So the angle doesn't really affect the valley number as far as what I'm shooting for based on that.
Our next question from Rich, I think we just addressed that about taking your readings in the honing machine or outside and how clean it should be. Yes, you want a clean cylinder. Derek, is there a rule of thumb?
Yeah, it's got to be clean. As Ed said, if you run the numbers and you get all of a sudden this big blip, that's a I'll use the word tick turd. That's something that's in the bore. So you want it doesn't need to be, operating theater clean, but it needs to be clean.
Okay, and do we have Ed and Lake back now?
We are back, yes.
Hey,
Sorry.
welcome back. Okay. All right. We're getting toward the bottom of the questions here, and we're really losing a lot of people. So is there a rule of thumb that is used when determining if a block is Nicosil?
Well, I mean, that's one of those things that you need to, we'll say, do your homework. You want to find out what it is you have. Most Nicosils are going to go over a straight aluminum block. So if you look at it, if you're looking at the deck surfaces or down off the main, you're not going to see the liner. Typically a linered block into aluminum, you can see that liner, where it's been decked. Nicosil, you're not going to see that. You're just going to see straight aluminum and then the coated bore. And the Nicosil's typically kind of a slightly yellowish color. So that's going to be the first telltale, but you definitely want to be real careful, because if you go in and do the wrong thing to it, it's very easy to destroy. I had a gentleman do a Sumi bore coated block, which is very black in color. And I was at his shop and he's like, what's all this gray stuff coming out of the cylinder? And destroyed a $10,000 Sumi bore coated block because he didn't realize that's what he had. So yeah, if you got something unusual there, you want to ask some questions first.
Yeah, you might even look into the port area. If it's a 2-cycle, you might even look into the port area. When they're plating that Nicosil on there, that'll tend to kind of overspray into the cylinder. Or I'm sorry, not into the cylinder, into the port area.
Okay, he's also asking if you're adding turbos to a NA block, naturally aspirated, I assume, would you recommend adding a wire ring to seal the cylinders and use gapless rings?
That's Keith's got a question right there. And I think I already know the answer. Go for it, Keith.
Well, yeah, I mean, as far as those are two kind of different things. As far as the gapless ring, yeah, I love the gapless ring in a forced induction application. It lets you get away with big end gaps. You don't have to worry about ring butting. It eliminates the blow-by problem, especially if it's I'll call a multi-purpose application. Street car, race car, track day. We've got to set all the clearances for the worst case scenario, whether it be ring end gaps or piston to wall, bearing clearance. Everything's got to be set for the worst case. But the 95% of the time it's not running the worst case. The gapless eliminates all the blow-by. As far as O-ringing the block, I mean, that may be necessary. There are extreme applications out there where we actually produce a cylinder head hoop. It's a one-piece solid ring that goes in there to achieve that. So if you've got a fairly extreme environment that's having a real hard time with head gasket seal, then yeah, that hoop ring is absolutely essential.
From Elias, what about silicone carbide brushes to make the Plateau finish?
The silicon carbide brush is not going to hone off the peaks. It will round the peaks, and yes, your RPK value will be better than if it was just a standard abrasive, but you're never going to obtain in my opinion, you're never going to obtain a true Plateau finish with a hone or brush, because it's not what I would call a rigid piece. So in other words, those brushes are flexing. So if you just picture that, they're going down in the valley, out of the valley, down in the valley, out of the valley, and so it's just very difficult to get a true Plateau with a brush, and there's probably a bunch of people that are going to kill me for that, but that's my.
Okay, next one from William. What are your recommendations about running a nylon brush backwards on a drill during the cleaning?
I can tell you that I have run Plateau honing tools or the brush style tools And I have run them both forwards and backwards to, kind of on the concept of a crankshaft. When you grind it one direction, you polish it the opposite direction to try to get the nodules off of it or pull them away. I have not found any measurable difference on the profilometer by running it forward or backward. Now it may clean better. I don't know, but as far as advantageous as far as a surface finish goes, I've not found any difference. Keith, you got any comments?
Yeah, I kind of agree with Ed. Having used those and played with those, and I have customers that will run them both directions. I've not seen, using the tools, a measurable difference. I guess what I'll say, I've seen going forward versus backwards, it might have got them where they wanted to go a little quicker. Cleans the abrasive better. So I do have people that do that, and they seem to have good results, but the measured numbers didn't really vary.
Yep, good point. You're right. I think it would clean a little faster.
Okay, from Matt. Does a softer block, say a 160 Bernal, need to have more RVK and less RPK to not put iron in the oil? Also,
we answered that one already.
Yeah, okay. And do methanol engines need more RVK?
Yes.
Yes.
Pretty clear there.
Yes.
Okay, from Paul. How well does retrofitting a CV616 with diamonds work to get consistent RVK values?
You're asking the wrong guy.
Yeah, the biggest issue that you have there is horsepower. You need horsepower to turn diamond, and I will advise when you're using diamond, there's higher cutting pressures involved with diamond abrasives. So you want to dissipate that cutting pressure over a greater air surface area. So, we talk about roundness, and there's no real true way to measure roundness with a dial bore gauge. So we've done a bunch of tests and used a pat or an incometer, pat gauge or an incometer to try to check true roundness. And I can tell you that a 4-stone hone head gives you a better roundness than a 2-stone, and a 6-stone gives you a better roundness than a 4-stone, and an 8-stone gives you a better roundness than a 6-stone. Now, at 6 stones, it's the law of diminishing returns. Does it get better? Yes, it does. Is it worth the extra cost of buying, 8 abrasives instead of 6 and a different hone head and all? We don't think it is. You're talking a micron or two between like a 6 and an 8-stone versus probably a tenth and a half in roundness, a 4 and a 6.
Okay, our next question from Kenneth. He's asking about honing with Blazer Coolant Grind 10. Yes or no?
Probably Blazer Swiss lube, especially speaking about a specific oil or coolant. Without knowing all the details, it's hard to say. So that would be send somebody an email on that one.
Okay. From Jules. I was taught to do a final clean of the cylinder walls with Scotch-Brite to take the edges off. Fact or myth? I think I could almost answer that, but I'm going to leave it to the experts.
Well, my opinion is you spend a lot of money on a honing machine, and a lot of money on abrasives, and a lot of money on coolants or lubricants and all of that. And I know guys that swear by that, but if you're doing the right thing, I don't think that's a necessary step. Keith, you may agree or disagree.
The ring's going to do more just assembling the motor than that's going to do. You're wasting your time. That's my opinion.
Yeah.
I
think what we're talking about here is, it's like driving to the store. There's 5 ways of getting to the store, but the end result is getting to the store. So that's kind of what we're seeing here. I mean, God rest his soul, Bob Glidden. I mean, Bob's trick back in the day was wrap the hone head with wet and dry sandpaper. I mean, he'd hone it, bring it to size, and go in with multiple different stages of wet and dry sandpaper because that's what worked for him. But with today's equipment and today's abrasives and today's machine, there's just really no reason to do that. Let the stones do their work and be done.
Yep. John Lingenfelter was another one. He was the same way.
And how do you keep
John was the same way? Yep.
how do you keep a consistent finish by using a Scotch-Brite, going back over what the machine's done?
You
can't.
don't.
You don't. That's what I'm saying.
You have no control.
You don't.
Okay, Matt is asking Keith. Keith, using silicon carbide on cast iron, do you use 400 grit as the final plateau, or do you have a favorite final stone or final method?
Well, Ed kind of really already touched on this, but yeah, that's generally 400 in a vitrified is going to get you that RPK number that you want. But as we said before, you've got to start off with a very aggressive stone before that so that you leave the valley. It's, you know, when you're looking at these numbers, your RP, RK, RVK, typically when you get it to size, your number is going to kind of be really skewed. Your RK is probably way higher than your VK. Your PK is going to be a little lower. And we're coming in with that 400 and slowly aligning and flipping those numbers. But it's a matter, as Ed said, we have to check it along the way. Don't wait till let's call it delivered the baby, to check on things. You want to, kind of look at it as the process is going and not overdo it, because again, we talked about the final grit being the PK number. Well, you can kill the other numbers if you keep going. Like we said earlier, we're talking microns. If you just keep going with that final stone, you're going to wipe out everything that was there before and just end up with a single stage finish. So 400 is the one, but watch it as you go.
Okay, Matt would like to know, do thicker rings need RPK, say a 1/16 versus 1 millimeter? Do they? I suspect he's asking, you need to change the RPK based upon the ring thickness.
I don't really change that. That's pretty constant from my point of view. What changes with thinner and lighter rings, lower drag stuff, again, is the RVK number. We may adjust that based on oil ring tensions. But as far as the peak numbers, I don't really play with that. Blake, Ed, I don't know if you guys got a thought on that.
No, I'm in full agreement, Keith.
Yeah.
Okay, and Dan has verified that on those Harleys that they are absolutely steel liners. Okay. From Paul, what would be the best honing procedure with vitrified stones to make ring seal on new engines starting out with 0 weight, fully synthetic oils? That's just slightly different than what we've addressed before.
Yeah, you have to know what the application is, I would think. Is it what I call the grocery getter? We're going back and forth to the grocery store, or is it a dirt track motor, a drag race motor, a boosted motor? I don't know. Keith, you have any?
Yeah, we need to know more specifics about it. I mean, there's, my daily driver runs a 020. So, we got to know a little bit more about the specific application.
All right. Terry wants a clarification on cleaning the cylinder. He says, what do you use to clean the cylinder when you're trying to get an accurate reading?
Oh, okay.
It was turned off.
Lint-free rag and I'll spray a lint-free rag with brake clean.
That works.
Okay.
Yeah,
Chris.
That's pretty much it. Clear solvent and a lint-free rag. Yep.
Chris is asking, I've had issues with gap and 2-piece gapless top rings aligning in operation. Is there a way to avoid this, or is this normal?
Well, to answer that question, all rings rotate. Generally speaking, at some point in time, the rings may line up, but they should unalign. They should continue to go back around. If I run into an engine that keeps lining up the rings all the time, that's usually a product of crosshatch angle, being ring rotation speeds are too fast, and or a couple other things are into light detonation. Light detonation can do that. Real loose ring-to-ring groove clearances, can do that. But most of the time, I'd have to say 90% of the time, if I have a customer that has an engine that just keeps wanting to line up the rings, it's almost always crosshatch angle. It's too vertical. And it's trying to find everything's trying to find the easiest way out. And once it aligns the rings, they'll stay there. With a flatter angle, it doesn't rotate as quickly and less likely. But we do also have on the rail what we call our slant gap. It's cut at 45-degree angle. So if you've got an engine that's kind of prone to doing that, just when you order the rings, order the slant gap. So now you've got, you know, a 90 degree and a 45. Even if they do align, it's still blocked off.
Okay. Anthony is asking, what is the base price on an H85? Ed, I think I'll just defer that back to you through email. You'll get a list of all the attendees and any questions they've asked along with their email addresses. So there's so many variables, I'm sure, that goes into that it's pretty difficult to address here. Zachary, what kind of roughing and finishing pressures are you using on the H85 series hone? Well, you've addressed that a lot.
And that's a great question. It's super critical on your wall thickness of your block. If I have for instance, a Dart little M or a big M or something like that, really good wall thickness, really stout block, I'll run 60% roughing and 50% finishing loads. But if I've got I don't know, I hate to, but if you have a thin wall block or you've got a sleeve in there and you're getting what I call some odd measurements, you're measuring your cylinder and you're down 3 inches or you're down 2 inches or you're down 4 inches and everything's good and straight, and suddenly you've got a 0.5 thousandths variation in your size, then that's a breathing issue. And so we go down in pressure. Yesterday here at RYR, we were actually honing a block at 20% roughing and 15% finishing, because that's what it took with a 6-stone hone head to make good round straight cylinders, because we had some breathing unsupported areas of the cylinder that were flexing as the hone was passing through it. So those don't hone. So it's really predicated on your structure or design of your block, I guess. But as a rule of thumb, 40 roughing, 30 finishing is where I start everything, and then I adapt I compensate from there.
From Mike, what fluid or product do you recommend to use as rings are inserted into the bores?
The Quick Seat is a really great product for assembly because it's a dry film lubricant. It doesn't need that speed, which you don't have when you're doing assembly, to help protect the ring and the bore from any kind of welding, scuffing going on during assembly, especially with high tension rings. So you get it nice and clean. You can do the Quick Seat, and then just some assembly lube, motor oil type stuff on the skirt so that the skirt's not dry. That's all you need.
Okay, Paul is clarifying his previous question about ring seal with zero weight oils. He's talking about stock engine rebuilds such as Subarus, Mini Coopers, late model LS engines.
Man, if you're going to try to put zero weight synthetic right back in those things as a stock rebuild, you better be on your game in terms of your hone and your finish and what rings you're using for that, because synthetic oil gives you almost no margin of error. So if you're going to be building those engines and the customers are going to use synthetic, you should probably look at using a break-in oil as your first oil change to give yourself some window of opportunity to get those things to seat in. And then that's a tough ask without, the OEMs at that level to do that work for fuel economy, which is why they do it. They have invested heavily in their machines and their process in order to make that happen. That's just not something you fall off the turnip truck and just happens.
Very good. Okay, I want to thank all of you folks who have stayed with us as long as you have. I know we've really run over, but boy, I'll tell you, the comments we're getting from people on what a great panel it was. It's heartwarming. Okay, I'm going to take the presentation back, guys.
All right. Thank you.
Thanks.
Okay.
Thank you.
All right, so in closing, I want to thank Ed, Keith, and Lake. I'm sure everyone got the answers they've sought for a long time, and your clear answers to what makes a good finish and how it relates to ring performance will go a long way in improving the engines our industry remanufactures. And I'll tell you, it sure was an eye-opener for me. So many of these webinars are this way. The session has been recorded. You'll automatically receive a link to it. The file is too large to email and is viewed online through GoToWebinar, and you'll receive that link no later than Friday, October 23rd. Also, keep in mind that you can always access these recordings at www.pera.org on the webinars page. And I believe this is 63 for us, so there's quite a library there. Our next webinar is going to be on November 11th. Yes, the 11th. We've moved it up due to the Thanksgiving holiday. It's going to be presented by Tim Foster of Melling Engine Parts and will be all about internal wear and its effect on oil pump performance. I can tell you Melling's been doing a lot of work in this area, so it's going to be real informative for you. So tune into that one. Please send your feedback, good or bad, to Joe Polich at pera.org. If you have suggestions for future webinars, please send that as well. And now is the time. We're starting to finalize that 2021 schedule, so I still have a few open spots. So if you have any recommendations, please send those to me right away. Any closing comments, Ed or Keith or Lake?
I just thank everybody for the opportunity, and I've enjoyed it. I sure enjoy being here with Lake and talking to Keith. I always learn something when I'm around these guys.
Same here.
And I was going to say likewise. I really appreciate everybody taking the time out of your day. And Joe and the PRA folks, for presenting. This is just a great opportunity to try to spread information and get it out to everybody. And at the same time, the seminar that's going to be in January, I know the format. I know how this thing's going to be laid out, folks. I'm telling you, I'm not trying to sound like a commercial. If you enjoyed what we did today, that is going to blow your socks off. So you need to sign up for that thing because it's really going to be a killer deal.
Okay, very good. I'd like to again thank special thanks to everyone for taking your time from this schedule, from Ed, Keith, and Lake, and Rottler, and Total Seal, and CWT Industries, the Durbon Bearing Company, ERI of Canada, Hastings Manufacturing Company, King Engine Bearings, Mala Aftermarket, and Qualcast LLC to bring you this really important program. This concludes today's webinar. Have a terrific day, and please stay safe.